Discovery, go at throttle up.
Space and Rocket Review. Space and Rocket Review. YouTube chats, tell your friends. Space and Rocket Review. And it's Membies night at the EJSA. What's going on, everybody? How are you? Welcome to the Eric Johnson Space and Rocket Review. Mr. Man! Mr. Man! Mr. Man! They left this number. Maybe I help you? You tell your friends. I already tell my friends all the time. It's just really an awkward conversation when I tell my friends about this because, you know, like, you know, they, you know, I have to go through that awkward conversation about, you know, what do you do? Oh, that's what you do? And the other day I was talking to one of my neighbor's friends. The other day I was talking to one of my neighbor's friends, and he was like, why do you have to work at like super late at night? I go, sometimes that's when work happens. Sometimes that's when rocket launches are. He's like, what do you mean rocket launches? I'm like, dude, I've told you this so many times. I don't remember. What do you do? I'm like, so I had to have that conversation, you know, it's not. Who's Eric Johnson? He's a guitar player. I am a contractor for Amazon. Yeah. That's not totally a lie. I mean, it kind of is, but. Tell him you're the launch director for NASA working remotely. They'd probably believe that, you know. All right. Got a little bit of space news for you here. Got some good stuff, got some interesting stuff. Let's start off with a video from Relativity. This is their August 2025 program update, and we will not be able to listen to any of it because it usually has music. So, I will narrate this. Terran R update, August 2025. August was a big month for our program. Let's recap key milestones across design, build, test, and launch. This month, the team has completed 18 component-level critical design reviews, many of which were for the second stage engine. The second stage engine, probably avionics, or fluid components. Released all machine fluid components for the thrust structure. All machine fluid components for the thrust structure have now been released, including all valve components. The stage engineering teams, including structures, mechanisms, and fluids, continue to work hard to close designs for Stage 1 and Stage 2. Recently, Relativity's first composite parts and increasing their focus on reused systems such as landing legs. The thrust structure build is complete. Thrust structure is one of the most intricate and complex parts of the vehicle, so its build required tight collaboration between dozens of teams across the company, as well as the introduction of advanced manufacturing methods to enable high-rate production. In parallel, we finished welding the final Stage 1 barrels for the first flight on the vertical friction stir welder. Now, all 8 first stage and 2 stage barrels for Terran R's first flight have been welded. The Aeon engine. Yep. With barrels complete, first stage tank weldage has begun. First circumferential friction stir weld is complete, joining two full barrels together. Separately, welding on the first stage downcomer is in progress. The manufacturing team activated the paint booth this month, marking another major production capability now online at our factory. Manufacturing assembly of the first flight engine is complete. It has been shipped to NASA Stennis, where it will be installed on our test stand for acceptance testing. Factory team activated the structural test stand in Long Beach that will test the thrust structure and first and second stages. Activation was the culmination of years of work and involved building structural and fluid systems, integrated data systems, loading software, and configuring IT systems. The stand is capable of 6 million pounds of compression, 170,000 pounds of shear, and pressures up to 250 pounds per square inch. Cool. EJ was a newscaster in a previous live. The thrust structure was loaded onto the stand and began multi-week acceptance testing. Stand, we tested a flight case simulating max Q and preparing for a hold down case replicating conditions on the launch pad. At NASA Stennis, we began hot firing a development article of our second stage vacuum engine, Aeon B. We successfully demonstrated operations across throttle, mixture ratio, and gimbal ranges. The first stage flight engine is being prepared for the upcoming acceptance testing on the second bay of the dual bay test stand. 9 commodity tanks arrived at NASA Stennis for the A2 structural test stand. Once installed, they will be capable of storing 650,000 gallons of liquid oxygen, liquefied natural gas, and liquid nitrogen to support stage testing. In avionics, the team made significant progress on the path to completing the vehicle-level hardware in the loop testing this year. Initial avionics hardware has been integrated into the system, and the ground software equipment was used to successfully send commands and receive data from the ground hardware to avionics. The first version of vehicle software has been deployed to the avionics system, layering the groundwork for future testing and mission operations. At Cape Canaveral, site work continues to accelerate. This month, we completed a major concrete pour for the transport erector cap. This TE cap will bear the loads of the vertically ellipting, fully integrated Terranar vehicle. Made it to the transporter erector. Water tower fabrication is also progressing, with most of the large storage tank welded, and the installation of stanchions for above-ground piping systems is underway to support commodity flow across Launch Complex 16. From progress on primary structures and engine testing to enabling infrastructure, August has been another busy month on the path to Terranar's first flight. Stay tuned for more. All right, let me see. Let's go back and take a look. Interesting. Huh. Terranar is bigger than Falcon 9, guys. Not by much, but it is a little bit bigger. That video is old. It looks so much different. I'd believe it. Yeah, that was definitely Long Beach. Yep. The relativity works out of the former McDonnell Douglas C-17 assembly facilities. Yeah, this was a C-17 production line. There was 2 of them. There's another one over there. They would make C-17s right here. It's really funny. I heard the other day that the Air Force wants more C-17s. Whoops. How does this stack up to a Falcon 9? It's just a little bit higher payload to low Earth orbit than a Falcon 9. It's a little bit taller and a little bit more payload. This thing can do 20... Terran R will be able to do what, guys? Like, I think it's 25 tons to LEO. It's pretty good. It's a pretty good little rocket. My thing is what gets me about this damn thing is that the thrust structure looks real good if you're using 9 engines. Terranar is not using 9 engines. It's using 13 in the first stage. The reason why they're doing 13 engines is, well, they kind of realized that their engines weren't able to... The engines were a little bit more difficult to make, so their engines didn't come out as powerful as they wanted, so their solution to that was just to add 4 more of them. It has 13 engines in the first stage. It was supposed to have 9, but they also were supposed to be a full flow stage combustion cycle, and now they're not. They're just gas generators. Where's that picture of the thrust structure? Let me see something here. So their thrust structure will have the 9 engines, right? But there's like 4 engines on the outside in 4 times symmetry on top of that. 23.5 downrange landing or 33.5 expendable. Thank you, Helmus. Ah, I got you. Yeah, they... That's also their thrust vector control system. It was supposed to have 7 full flow stage combustion cycle engines with same performance as the BE4. Yeah. Yeah, that's a way to do that. Yeah, that's a way to do this. Interesting. They seem to be doing thrust qualification testing totally at ambient temperature. You got a pretty significant strength boost at cryo, even with an aluminum structure. Really? I guess that makes sense. I guess maybe it doesn't get super cold. Yeah, I noticed that too. This is why I wanted to specifically see this next picture here. Yep. So they got billet aluminum for the thrust structure here. They have a main thrust puck in the center. And this is all bolt together, Prey. You see that? No welds. It's all bolted. Check it out, dudes. Look, do you see any welds? I don't see any welds. See any welds? This thing's bolted together. I'd assume the tank dome is higher up. Yeah. Billet mentioned, yeah, they're using an ISO grid on these billet thrust structures here. I mean, Prey, also, judging by this, it looks like the bottom of the dome piece is probably going to be right here. Bottom of the dome's probably like right there, if I'm looking at this right. Because I'm thinking the barrel segment is probably right here on that anodized component, right? That's where the barrel segment is. So the dome's got to go down a little bit, right? I'm going to say it's probably the bottom of the dome is probably right where this ridge is. The bottom of your fuel tank. The fuel tanks are pill-shaped, so the bottom of it is hemispherical, guys. A bolted thrust structure makes sense. The only way to hit these welds is by a TIG MIG head, and you're going to be designing entirely around has strength, which is way weaker in aluminum. Yep. Yeah. It's getting awfully Falcon 9 Block 5 in here, don't you think? Wait a minute. Is this upside down? Is that... Not upside down. Yeah, Baron, this... Okay, it's not. All right. This is... Here, fellas, check this out. Look. Oh, my goodness. Hey, Chris. 108 month resub. Thank you. Dude. Bolting is fine. It's just heavier than fully welded. There's a trade-off right there. It's hard to weld something like that together, dudes. And because that's way easier to manufacture, but it's also a little bit more mass. But yeah, way easier to make. Pray. Wait a minute. Where's this? Where's the bottom piece? Where's the boat tail? It's not there. Oh, no. I mean... Yeah, okay. All right, I see it. Yeah, that's that. Yeah, I got you. I got it. I just... Yeah, Bazdon, you're not wrong. Finding skilled welders in Los Angeles isn't easy. Really? Really, Institute? The Institute of Snobbish Intellectualism. Well, I think that Muir's comment is rather shallow and pedantic. I think finding welders in the greater Los Angeles area is actually easy to do. No, I'm just kidding, man. Sorry, your name makes me laugh. Why do you say that, though? Once upon a time, there was a huge aerospace industry in California. You'd think there'd be a bunch of people that know how to TIG weld. Am I giving them too much credit? We did see that they put a landfill next to a water treatment plant when we were playing cities yesterday and looking for reference. $1 million average home price. I'm not following. What does a home price have to do with it? What, welders can't afford to live in Los Angeles? Oh, I mean, I suppose. Welding is known in the state of California to cause cancer, just like everything else. You know that living causes cancer too, Tape. Is California going to warn us about that too? Yes, shallow and pedantic. Nobody can afford to live in LA. Fellas. I know. You know where I'm from, right? Remember that? Remember that part? Oh, believe me. I know what it's like to be priced out of your neighborhood. It ain't fun. I bet that bolted is lighter since you'd want to use a hard alloy like 775, which has really great strength to weight ratio. Once you weld a weldable aluminum alloy, the strength knockdown can be more than 60% due to parent annealing and joint efficiency. Today I learned, dude. No, believe me, I get it. I live way outside of Boston at this point, guys. And guess what? Guess what? There's all a bunch of blue collar workers around me. It's all trades, it's all HVAC guys, mechanical, carpenters. It's great, man. If I have a problem with the house, there's like 30 people on my street that can fix it. And that's if I can't fix it. So, you know. Not a lot of failed actors know how to Remember, actors do it on cue. Turn in your badge and your weapon. I don't want to see you near this investigation again. Turn in your badge and your weapon. No? All right. Yeah, goalie, that's the gist of it, yes. You need a solution to anneal then bake the whole thing to re-age back to the precipitation strength and condition, which typically, this is regarding welding, which typically comes with a ton of dimensional change since you're actually moving around atoms in the crystal lattice that makes up the material. Jesus, man, you've learned a lot since the last time we've talked. Everybody got that? Gator needs scat. Yep. Sadly, I'm from California, and the cost of living was crazy when you left. Now, I get it, man. I get it. I get it. It's lame. It's a shame, dude. I mean, the prices. California used to cost nothing to live there, dude. I remember back in the day, like when I was in high school, used to go out there, and yeah, it's not expensive. And I was like, damn, dude, I kind of want to move here. There's cars and space stuff and cars and space stuff. There's also cars and space stuff in Florida, which is why I also like Florida. Florida has that humidity, though. We're talking like circa 2005. California's pretty sweet deal. Nowadays, yeah, it is expensive, but so is my state. So I get it. I get you. I get you. Texas has cars and space stuff now too. Yeah. It fits the bill, but not as much as Florida does. Florida's my... Anyway, cool update from Relativity. It's good stuff, dude. Good stuff. I mean, this is all... I mean, Prey, the other thing is that, I mean, not that I'm adding much to the conversation. It's a little one-sided, but that's how I like it. This is all... It's all anodized, too. They anodized everything. I wonder why they painted the outside and not anodized it like the rest of the thrust structure. I mean, that could be anodized and painted, but... I don't know. Last time, if I'm remembering right, you don't... Painting anodized aluminum doesn't really end well. Damn, look at how beefy that thing is. So, fellas, if you guys are very curious of what you're looking at, you're not looking at a time machine. All right? This is a gigantic hydraulic press. And what it's trying to do is, right here is all the engine, it's the engine mounts. It's called a thrust structure in rocketry. The thrust structure. This is where you mount all the engines, right? That's what it's supposed to look like with all the engines in it. I mean, obviously it's going to have paneling on the sides and stuff, right? This is what it's supposed to look like. The thing that's in the can crusher right there, that big hydraulic press, is that minus the motors. You don't want to crush those. So what this is here to do is basically test on how well their analysis was on having 13 of those engines push on this. So the engines are going to be pushing obviously from the bottom. So what this thing does is it pushes down on it, and then on the engine mounts they have a strut right there that connects back to the stand, right? So when you push down, your points of load are going to be through the engine mounts, right there, right there, right there. Every time you see one of these things, that's where a motor is going to end up. There's another one behind this one. It's kind of hard to see. The idea is that, well, you know that this thing won't crush itself when you go to fire the rocket engine, when the thing goes to fly. They tested it for max Q. They tested it for liftoff. They tested it for a bunch of things, which is pretty good. This is good testing. I mean, it's kind of industry standard, but it is cool to see. And it also looks like a TARDIS or something. Hydraulic press channel got a budget increase? Yes. It's good that you got barrel segments here, but you need domes for those too. The shot with the test stand in the woods, is that the same one we saw a while ago? Some guys filming a live fire test from only a few hundred meters away? This is at Stennis. I'm not 100% sure. They have a 2-cell test stand right here. With 2 flame buckets for testing the motors. Hello, EJ. Technically, it could press olives to do olive oil. I mean, Quartz, I'm not going to say that I wouldn't want that. Right, did 4 years of school and 3 internships since I was last in here often. Moving to Brownsville in January, so I mostly have to lurk now for obvious reasons, unless covering other companies. Have you on permasub. Might not have ended up here if I hadn't gotten into KSP. Feels strong, man. Hey, my dude. Well, Pray, the next time I'm down there, dude, we're gonna have to go to Hopper House and hang out. Beer's on you, boy. Just saying. It's a business expense, you know. It's a business meeting, technically. If we talk about the streams, it's a business meeting with it's a business meeting with industry experts. Right? Right? What is that structure next to the dock? Oh, in this shot right here, ship watching? So that is a NASA test stand. That's the B1, B2 test stand. This hunk of metal here was built back in the day to test Saturn V first stages. It's a 2-cell test stand as well, albeit a lot bigger than Rocket Lab, or not Rocket Lab, than Relativity's stand. Rocket Lab's stand is actually over there. It's behind those trees. You can't see it in this picture. This camera's facing the wrong direction. Careful, that phrase will put your accountant in the hospital. No. No. So yeah, that's the B1 and B2 test stands. They were built during the Apollo program, and they were built to test Saturn V first stages. That's why you could see the provisions here are in place for it to be able to pick up. See the big crane up there? They could pick up a Saturn V first stage and drop it in the test stand. I might have pictures of it. Here, hold on. There's one in the VAB. Yeah, there you go. So that's that motor, or that stage right there is SA500. That's SA500D. That is the Saturn V structural testing article. That stage is still around. That's the first stage. That's at Kennedy Space Center. If you ever go to Kennedy Space Center visitors, the Saturn V that's there, fun fact, that ain't a Saturn V first stage. It's the test article. They fitted the test article with real engines for the display. Yeah, it's SA500D. That's the name of the testing article. Also, yeah, that's the B1, B2 test stand. Look at that thing back in the day, dude. What a monster. That crane, the cranes are still there. They still have the cranes up there. You could use them. You could use them for something. NASA. You could use them for something. Just saying. Also, what do we got over here? Got over here. Chevy. Ford. Volkswagen. Dude, 2 country squires. Hell yeah, man. What do we got down there? An Oldsmobile? And then a Mustang down there on the end. Nice. 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 Would it be possible to convert a test article into a flight article? Yeah, of course, Archie. Sure. Duh, they did. SA500D, for all intents and purposes, it's a real thing. They just, when they were using it for structural testing, you don't want to be toting around real rocket engines, so they have basically a steel mock-up of an F1. Actually, fun fact, there is one real F1 on SA500 in this picture, see? It's a real one. SA500 is a real thing. It's a real Saturn V stage. Look, you can see the separator motors there too. Yeah, the SEP motors for the first stage are in the nacelles on the bottom of the Saturn V. They were probably using it for fitment and integration testing. Well, they're using it for integration testing on the stand here. But, yeah, SA500 is a real Saturn V stage. They just designated it the test article. But many times throughout spaceflight history, they've taken a test article and they've refitted it. I can give you another example if you want. Give me one sec. Anybody know what that is? Are they going to put the EUS on the B1 test stand? Or the B2 test stand? Yeah. Yes, the B2 test stand was last used for the SLS core green run. And I contend to say, Hellfish, that NASA should be using the B2 for green run testing for all core stages from now on. What? What, are the engines not reusable? I don't think you have to worry about that. And then reconfigure the B1 test cell for upper stages, but they won't do that. They won't do that. So that right there is the structural testing article from the shuttle program, the STA. That is orbiter serial number 099 or 099, right? The STA ended up becoming Challenger. That's a shuttle Challenger. It started as a test article. Oh yeah, that's happened many times. Dad would be proud of the wagons. I love those wagons, dude. Those country squires, man. Bring back station wagons, all right? There's my car rant for the day. Bring back station wagons. That's it. That's the tweet. Anyway, yeah, that's the B1, B2 test stand right there. There it is. Seen better days, but you can see they converted it for a bunch of different things. The left side test stand, the B1 test cell, NASA actually leased to Aerojet Rocketdyne, and they used it for RS-68 testing. And also Delta IV testing back in the day. The Delta IV CBC, serial number 1, was tested here, and then they used it for RS-68 testing. You can see the hydrogen and oxygen tanks that they just mounted up there so they could put one single engine on this gigantic honking test stand, which just pisses me off. What a waste. What a freaking waste, dude. Anyway, with wood paneling, right? Right? Sorry? Yeah. Bring back station wagons with wood paneling. That's it. That's the tweet. But Volvo too? No, we just do that. There we go. That's fine. Bring back station wagons with fake wood trim on the sides. That's it. That's the post. There you go. Done. All right. No apostrophe on wagons? It's too late now, dude. It's not, though. I can edit it. I can edit it. I've edited it with no apostrophe. That's it. That's the apostrophe. Whatever, dude. Live tweeting is a vibe, all right? You have to vibe it out. It's just the way she goes, man. All right. What else do we got for space news? So, Blue Origin's Mars Telecommunications Orbiter offers continuous, robust communications provided by multiple high-rate links supplemented by deployable UHF frequent relay satellites. What does that mean? High-speed communications with dependable coverage for existing and future needs. You edited it? Yeah, absolutely. Dude, my 18-year-old nephew has a Buick Regal Tour X. It's mint and he loves it. Nice. Wait, vibe tweeting. Using AI to tweet. Fake wood side mean real wood sides was a thing? Yeah. Yeah, dude. Would you like me to explain? There you go. You watched this, Goltech posted it earlier. Oh, yeah. I put that on there. That's cool. So Ford Ford made Woody wagons in the 1940s. These are called Woody wagons because station wagon is made out of wood. What Ford did was they hired coach builders, right, to build this. The reason why they did that, why they made half of the car out of wood, was to save materials for World War II. That was the idea. So they made Woody wagons, and then it kind of became a thing to put crappy wooden trim on the side of your station wagon. So if we type in Ford Country Squire, like we go 1965 Ford Country Squire, right? It became a tradition. Look at oh beautiful. Beautiful. I love it. I love it. It's so bad. It's so bad. I love it so much. Oh, look at it. Look at how brown it is. Oh, that's the best, dude. Look. It's so bad. I love it. I love it. I want one. I want one. Dude, we should build one. Oh. Killer, dude. That's what those cars were that were parked next to the Saturn in that picture that I just showed you. There were two Country Squires there. That 65, that exact year. Oh. Oh, it's so good. The power glove of cars. So blue is looking it's very interesting that blue is looking at Martian telecommunications. That's very interesting. Turn your Dodge into one. So Dodge didn't do the wood trim. The wood trim was a Ford thing. Now Dodge did make a 69 Coronet. Hold on. Wait a minute. Oh, that's paint. All right. Yeah, they painted it. And it looks terrible. Dodge did make a 69 Coronet wagon, and they're actually pretty rare. But they are lookers. Look. Oh. Oh. I do not hate that. That's my car. But with a roof going all the way to the back. That's pretty cool, man. That's just like mine, man. But that's just like mine, man. There it is. See, only mine is the sedan. That's pretty dope, man. That's pretty awesome. I like that. I love wagons. Wagons are, especially mid 60s station wagons. Even getting into the 70s, there's some really cool stuff. But it's space news. Let's get back to space news. The weight of that thing. Miles per gallon, man. That is your car with a mullet. Yeah. Favorite board game? No good games? No good God games? Favorite board game? Does Warhammer 40K count? Does that count? When Blue Origin is successful, will Bezos add the cap on the logo for the feather to slot into? I don't know. Check into the ER if you dig wagons that much. Oh, yeah, whatever. Whatever. Coronet wagon's sweet, right? That is a tabletop role-playing game, not a board game, so technically no. That's very gamist of you. I'm kind of offended. I don't know. What's my favorite board game? Risk. Risk is pretty damn good. I like Risk 2249. That's pretty damn good. Settlers of Catan is a pretty good one. I played a lot of Stratego with my dad back in the day. Stratego's a good time. Monopoly, you can't really lose with Monopoly. You just named some bad games. Bite me. Those are not bad games. You are wrong. And this is my stream, so you're incorrect. Stratego hate will not be tolerated. That's what I'm saying, man. Sorry is the one that pisses you off. Sorry is what makes you mad? Dude, you've never played Risk. Risk is how you lose friends. You will lose friends playing that game. Or get into a fist fight with one of your best friends. Oh, me and my friends, dude, 20 years ago, me and my friends would play Risk because we were nerds. So we'd go play Risk and yeah. Oh, dude, we got into shouting matches. There were fights. There were fights in my buddy's at my buddy's house in his basement. There were fights. Oh yeah. we start, you dumb. Why would you move that person there? You just screwed me and you screwed yourself too, you stupid mother. Oh, it was awesome. It was awesome. Yeah. Was he Italian too? No, that's the best part. Oh yeah. See, what I did when I played Risk, what I did is I just sat there. I didn't yell at anybody. I just sat there. Everybody's expecting me to make some crazy freaking move, right? It's like, oh, he's gonna rock the boat. Like, I mean, this probably reads for me, right? Oh, he's gonna rock the boat just for the sake of rocking the boat. He's gonna do something. He's unpredictable. He's gonna do something. And then I just played the most predictable game that I possibly could, and I always won. Just saying. Yeah. Everyone's like, oh, EJ's gonna do something crazy. He's gonna do something dumb. He's gonna do something crazy. You're gonna do something stupid because, you know, you're you and you're a contrarian, right? You're gonna do something crazy, and then I never did. There's a thing called chess boxing, which is just 3 minutes of chess, then 3 minutes of boxing, and repeat until either a KO or a checkmate. Now, I didn't win Risk all the time, but I usually was in the running to win. If I didn't win, I only lost by a little bit. Camping Australia intensifies? You're gonna win nothing if you go into Australia. I do like chess, though. Chess is fun. Hired assassin, are you here? What the hell is this? What is this AI slop that you put on my tweet? No! What are you doing? What the hell, man? I'm not liking this. You put wood trim on a Mustang? What's wrong with you? It ain't your grandmother's car. Man. Go on to the next news. It's wrong. Wrong. Good AI generated picture, though, but it's wrong. All right, we got something from Stoke here. Our team just wrapped Stage 2 structural qualifications for Nova. From cryo operations and 100-plus pressurization cycles automated by flight software to axial and shear loads, the structure proved it exceeds design margin. Huge milestones. Great work by every Stoke team that made it happen. Make it happen. Stage 2 structural testing qualification. There you go. It's another can crusher, just like Relativities, but that's for Stoke's second stage. Note that Stoke's second stage is not a cylinder. It is, in fact, tapered. It's got a high taper stage. No, seriously, Stoke's second stage is capsule-shaped. Even the engine is hemispherical shaped down the bottom. because they're going to reuse it. There's going to be a chopper fairing up at the top here. There's your stage, and you have a heat shield shaped engine. Stokes' heat shield shaped engine is called Andromeda, and it's really unorthodox by rocket standards. Like, really unorthodox. It is a very strange design. Yeah, Stoke came up with the idea of making an engine heat shield shaped. There it is. That's not a heat shield. That's the engine. And how a regular rocket engine would have cooling channels in the nozzle to keep the nozzle cool, Stoke has cooling channels in the heat shield on their Andromeda engine. They have cooling channels in the heat shield instead. So fuel gets pumped through the dang heat shield. The heat shield's made out of metal. It gets pumped through the heat shield, and then it goes to a bunch of small rocket engines around the edge. Now, this is just nozzles. This has one power pack in the center. The turbo pumps, the turbine machinery is in the center of the heat shield. And generally, with rocket engines, this is general. Sometimes this naming nomenclature doesn't add up exactly. But the amount of power packs you have, the amount of fuel pumps you have, denotes how many rocket engines you have. So you could have one power pack feeding 4 nozzles, like an RD-170, and that's one rocket engine. So this, per that naming, like that rule, right? That has one power pack in the center for fuel and oxidizer, and a bunch of small nozzles around the edge. That is one rocket engine. That is a rocket motor right there. What Stoke is going to do, right, is when their second stage comes back down, they will start flowing propellants through the cooling channels in the heat shield. And that'll pull all the reentry heat out of the metallic heat shield. Very similar to transpiration cooling, but backwards. What in God's name is the... Hired, I said no more Ford AI slop in here. I said no more. No more. Seriously, stop it. Seriously, what in the heck? What are you doing? What are you doing? Just make cars. Just make cars. Make cars. Is this hard? Just make cars. Like, nope. We're gonna make a bike. No, just make cars. You are Ford. You practically invented the stupid thing. I know that Benz invented the first car. Shut up. Anyway, Stokes engine, super cool. Super cool. Yeah, and this is going to be attached to the bottom of that thing right there. Where the orange ring is, that's where the Andromeda engine is going to be. Pretty cool. Hold on a minute. What if it's a good product? I like a lot of Ford's recent stuff. Like, what recent stuff do you like? Meanwhile, Aston Martin is making this. No. 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 Oh my God. What are you doing? What are you doing? What are you doing? Stop it. Stop. Just make cars, man. You know what? I'll take the e-bike. That's fine. At least the e-bike is somewhat remotely, like, relevant. That is a baby carriage. That's a bit. Lance Stroller. That's good. That's good. I like that. It's the Lance Stroller. Just make cars. Just make cars. Just make cars. Can somebody please make like a full size or mid-size sedan or something with a V8 that's rear-wheel drive? Can somebody do that? Anyone? Anyone? No? More space news. Check this out from Firefly. Firefly Aerospace. Blue Ghost Mission 2 heading to the far side of the moon is bigger and bolder. And we have the team to make it happen. Standing over 22 feet tall, the structural qualification models for a Blue Ghost lander and Elytra Dark Orbiter were built and fit checked today at our Texas Rocket Ranch. Next up is testing. Holy jeez, look at this. No, we get a Dodge with a speaker that makes engine sounds. That's cool. This is making me happy because the car stuff was not. That's super sick, dude. Blue Ghost, baby. Whoa, wait a minute. I see some MLV hardware back there. Wait a minute. Were they supposed to show that? Because there's some MLV hardware back there. Nice. So Firefly has two launch vehicles right now. They have Alpha and Eclipse. Alpha's over there. See that thing? That cylinder over there on the far right? It's a cylinder, all right? And it's stuck. It's stuck in the cylinder. See that? That's Alpha. That's MLV. MLV is the Eclipse. That's the Eclipse launch vehicle. Dude, they did that on purpose. Look at the size of that damn core. That's huge for carbon fiber. That's awesome. Dude, I don't think they were... I don't know if they meant to do that. Maybe they did. Maybe they didn't. Either way. Dude, oh, that's awesome, man. The only way they can launch this is with an expendable Falcon 9 or a dedicated Vulcan. Blue kind of ghosted them. This flight is heavy. There's a Blue Ghost lander and an Elytra satellite carrier in the undercarrier. Yeah. Yeah, this is the satellite dispenser is inside of this thing. Yep. This is a payload attachment fitting. Or, well, it's a PAF adapter. Your attachment fitting is up there. Super cool, though, man. That's beast. I don't know. Fluffy, I'm only going and getting this picture because I like you. Okay? What? Why did... What did... Logan, why? Why are you doing this? Why are you doing this to me? I can't decide whether that's cool or not. I mean, I don't like that it goes down here like this. If it was just a wooden stripe that went down the side of the 7-3... Wait, what? Wait. God damn clankers. God damn clankers. I'm here for it. I like this. You know what? You know what, Autumn Dog? You get a like. Boom. Hellfish, CC, Ford, Volvo, and Cadillac. No. Yeah, I'll take this. That's fine. Yeah, you know, trucks from the 70s, sure. The thing is that the AI had some trouble generating the grill. That grill isn't right for a 1979 because that's a seven. This is it. The AI generated a 79, right? I don't know who Board is, but you know, and the blue oval isn't in the center on a 79 Ford. It just says Ford on the grill. All right, so 1979 Ford F100. Think. So that's actually sick, and I actually want it. Look at all the chrome, dude. Taste the chrome. But you know what? Yeah. Autumn Dog, you get a like. Look at that. Look at that. None of these other mental illnesses get a freaking like. Okay? That's ridiculous. Ridiculous. Okay, we got an OIG report, guys. This is NASA's Office of Inspector General. OIG reports to NASA are basically what an audit is an auditor is to the IRS. I was about to say what an auditor is to the IRS. Yep. What an auditor is to the Internal Revenue Service. All right. It's board because it uses a wood board on a Ford. Ah. Yeah, that makes sense. All right. Why we performed this audit? Can you let the Bostonian out on this one? In June 20, I'll try to talk how I normally talk, but it's not going to work. That ain't going to work like that, dude. In June 2019, NASA selected Dragonfly as the agency's next mission under its New Frontiers program, which seeks to answer questions about the solar system. Dragonfly, a rotorcraft lander with 8 engines that will fly like a large drone, is designed to gather sample materials from Saturn's largest moon, Titan, good name, and determine surface composition in different geological settings. The rotorcraft will be powered by a radioisotope power system and fly to dozens of locations to characterize the habitability of Titan's environment, investigate how far prebiotic chemistry has progressed, and look for prebiotic chemical processes, the precursors of the origin of life. Dragonfly is a principal investigator-led mission by the Johns Hopkins University Applied Physics Laboratory, APL, in Laurel, Maryland. Although at the time of selection, the mission was expected to launch in April of 2026. I know what's coming. Although at the time of selection, the mission was expected to launch in April of 2026, in September of 2020, NASA directed project officials to change Dragonfly's launch readiness date to July of 2027 due to the agency's inability to fund the project's plan. In January 2022, Dragonfly was approved to continue development with an updated estimated life cycle cost range of $2.1 to $2.5 billion, an expected launch date of June 2027. Then in March of 2023, NASA directed project officials to initiate a replan due to funding constraints. The replan, which was completed in July of 2023, included new costs, staffing, and schedule plans. As a result, the project estimated a new launch readiness date of July of 2028, with an expected arrival at Titan in 2034. By the time NASA formally established the project's cost and schedule baseline in April of 2024, lifecycle costs have grown to $3.35 billion, and the launch readiness date was delayed by over 2 years. In this audit, In this audit, we examined NASA's management of the Dragonfly project relative to cost, schedule, risk, and technical performance. Specifically, we assessed 1, whether the project had effective cost, schedule, and schedule plans in place, and if they were performing according to these plans, and 2, how the cost of the Dragonfly mission impacts the future of the New Frontiers program missions within the Planetary Science Division portfolio. Our assessment included a review of NASA and APL project documents such as the Dragonfly project plan, international agreements, acquisition planning, documentation, monthly status reports. Additionally, we interviewed NASA's officials from the Science Mission Directorate, PSD, I'm not sure what PSD, Planetary Science Division, and the Office of the Chief Financial Officer, the Radioisotope Power Systems Program Office, and APL project management officials. What we found. Dragonfly has experienced significant cost increases and scheduled delays, primarily due to decisions by NASA management. Surprise! Dragonfly was selected under a New Frontiers announcement of opportunity with an $850 million cost cap principal investigator managed mission costs. Which primarily includes development costs but excludes launch vehicle and post-launch operation costs. Can I read that again, guys? Dragonfly was selected under a New Frontiers announcement of opportunity with an $850 million cost cap on principal investigator managed mission costs. Okay. That means APL is paying for $850 million of it. It primarily includes development costs, but excludes launch vehicle and post-launch operations costs. Oh dear. However, by April of 2024, these costs had grown to $2.6 billion, and the launch was delayed by more than 2 years, from April 2026 to July of 2028. The cost increase and schedule delay were largely the result of NASA directing APL to conduct 4 replans between 2019 and 2023 early in Dragonfly's development. You remember what I said about who was watching the Kerbal stream that we did a little bit earlier? Do you guys remember what I said about changing stakeholder expectations during a project? Changing stakeholder expectations after you've clearly defined your goals and revising them gets exponentially expensive the further along you are in said project. If I want to build myself a rocket and I have, a rocket that can move 100 tons into LEO, right? That's a 2-stage vehicle. I want 2-stage, 100 tons to LEO. And then halfway through development, I decide that that's too difficult and I want 3 stages. The cost will balloon exponentially. The closer to the start of the project that you make that design decision, the cheaper it's going to be. Best case scenario, you don't change the expectations at all. There's 4 replans from NASA. So the stakeholder expectations of this project have been changed 4 times between 2019 and 2023. Justifications for these replans included COVID-19 pandemic, supply chain issues, changes to accommodate a heavy lift launch vehicle, projected funding challenges, and inflation. Frick all of you. Frick all of you. We also found that NASA allowed Dragonfly development to proceed under less than ideal circumstances. For example, while a NASA senior management review determined in November 2023 that Dragonfly had met the technical requirements to proceed to the next life cycle phase of development. Due to uncertainty in the fiscal year FY25 budget, management gave the project authority to begin the next phase work not to exceed the limits of FY 2024 funds, but did not formally authorize the project to continue into the next phase. Can I read that again just to make sure I understand this right? A senior management review determined in November 2023 that Dragonfly had met the technical requirements to proceed to the next life cycle phase of development. Due to uncertainty in the fiscal year FY 2025 budget, management gave the project authority to begin the next phases of work, not to exceed the limits of the fiscal year 2024 funds, but did not formally authorize the project to continue on to the next phase. Who's running this? Who's running this space agency? Seriously, who the hell's running this? It's ridiculous. Sean Duffy? This is not Sean Duffy's fault at all, Green. Look, man, that guy is not above criticism by any means. It looks like most of the, well, let's call it horse patootie happened between 2020 and 2024 here. Gee, that's weird. Although this authority is atypical and had not previously been used by the Science Mission Directorate, the decision allowed the project to begin development work instead of delaying that work until the agency completed the fiscal year 2025 budget process. In our opinion, considering the multiple delays and corresponding cost increases the project had already experienced, we believe the reasoning behind NASA's decision in limiting the project's work to existing fiscal year 2024 funds was sound. Yeah, okay. Dragonfly was subsequently granted authority to formally proceed to the next phase in April of 2024, with a cost baseline of $3.35 billion and a July of 2028 launch readiness date. However, despite establishment of cost and schedule baselines as of July of 2025, the Dragonfly project plan, dated February 2023, had not been updated to reflect the changes. Okay. Yeah, I don't mind them, using 2024 funds to go into the next phase of the project. In a vacuum, Prey, you're right. That sounds a lot worse than it is. That's a good decision. That's not a good decision. Saying the project is move on and then not telling anybody. That's not great. That reeks of bad management. Like, reeks. But then again, there's good management up here. We'll see. Let's see where this goes. In addition, NASA decided to allow Dragonfly to proceed into the next development phase with lower than optimum project cost reserves, known as unallocated future expenses. During final design and fabrication development what? No. In addition, NASA decided to allow Dragonfly to proceed into the next development phase with lower than optimum project cost reserves, known as unallocated future expenses, during final design and fabrication development work. Yeah, that's not the greatest decision. But so what happens? Final design and fabrication development work. That's basically when, for a project like this, what pertains to Dragonfly, is figuring out how all the pieces are going to go together. How do you build this thing? They come up with the entire manual for how to build it, and then they go and build it. That's the idea. You get all your blueprints done, you get all your design done in your preliminary design review. You go past critical design review, right? And when you get past CDR, that's when you start making things, okay? This is how NASA does it. This isn't necessarily how SpaceX does it, okay? So usually when you're getting to the end of a part of the project's life cycle, right? When you get to the end, you usually want to have some extra funds just to tie up any loose ends. Maybe you figured out that some guy, like somebody said that you wanted to use 10 millimeter bolts, right? And the 10 millimeter bolt maybe is too long. So now you might need to use an 8 millimeter bolt or something, right? You know, or something like that. We need to use a different bolt. These bolts are too long. They go too far and they hit something. We need to change it. All right. Okay, if we change it, we're going to have to go figure out everything that we already figured out to make sure that these bolts are okay to go in this design, right? This is just a hypothetical, but that's the idea. You have unallocated future expenses. It's basically hedging your bets against what's called unknown unknowns in critical design review. Unknown unknowns happen. You're not going to know how to put the stupid thing together until you go and put it together, or at least have a conversation and write the manual, the user guide of how to put this damn thing together, right? That's the difference between like how SpaceX does things and how NASA does things. NASA writes the entire book, right? You write out the entire book. You spend all your time writing this manual, right? And then you go and use it. The idea is that you really leave no mental stone unturned, right? SpaceX just builds it. And then they figure out what they need to fix and figure out what they want. And then they write the manual after the fact. That's the difference here between like iterative versus kind of garden variety aerospace engineering. Yeah, everything looks good on paper. The real world is different. It's called waterfall engineering. That's right, McGillicuddy. You got it. I don't know, Rares. We'll see. Let's keep reading. But yeah, not having unallocated future expenses going into final design and fabrication work, I already know. Like, I don't even need to read the next paragraph. I already know what's going to happen. They're going to run into an unknown, and they're not going to have the money to fix it. I'm telling you right now, that's what's going to happen. Let's read. This limited the project's ability to resolve unexpected technical problems and address risk. Oops. To address this shortfall, APL plans to rephase work and delay payments to some of its contractors. Project also plans to delay development and testing activities, which can lead to late risk identification and more costly risk mitigations in time and money later in development. Okay, just in case people think I'm full of crap, dude, I do not read, and I do this on purpose, I don't read ahead of what I've highlighted. So I didn't just read that while I was explaining cost allocation to you. I could have told you that was going to happen, even if this had been, like, behind fog of war. That's just systems engineering 101. Dragonfly's total life cycle cost is significantly more than other New Frontiers program missions, and will continue to absorb an increasing proportion of the Planetary Science Division's total budget. While other New Frontiers mission had total life cycle costs of approximately $1 billion, PSD budget limitations along with Dragonfly's increased costs have delayed the release of the next New Frontiers program announcement of opportunity. Holy crap. Dragonfly is sucking up so much money that the Planetary Science Division doesn't have the money to figure out where the next probes are going after Dragonfly. Yeah, that's what that sentence says. That's great. Right, Fluffy? For real. That's not the way you read that? Well, what do you mean that's not the way you read that? Well, other Frontiers mission had total life cycle costs of approximately $1 billion. PSD's budget limitations, along with Dragonfly's increased costs, have delayed the release of the next New Frontiers program announcement of opportunity. How could that possibly be misconstrued, Aqualux? What even is Dragonfly? You know what, dudes? I like Dragonfly for what it's worth. I think it's super cool. Dragonfly is a Perseverance rover with helicopter blades instead of rover wheels. Seriously. That's the Perseverance rover, like what we have on Mars. Remember how we sent a helicopter with it? There was a good reason for that. We sent Ingenuity with the thing because what NASA eventually wanted to do is take that rover chassis and put helicopter blades on it instead. And then use it to explore Titan. Beep. It's also done by Johns Hopkins instead of the Jet Propulsion Laboratory, correct? But it is the same thing. That's a Perseverance rover chassis with helicopter blades on it. Stuff like this is why I can't get angry over the proposed cuts. Yeah. Aqualex, in the context of the rest of what's being read, I read that as not knowing how much Dragonfly will cost is making them uncertain about what they can announce. How is that any different than what I said? No. Let's just skip this conversation. That's what I said is right. I know that what I said is correct. You think it's just, they don't want to announcement. I'm telling you that they don't have the money to do it. They don't have the money to do it because of that uncertainty. But we're flipping the same coin, dude. So let's keep reading. In addition, where other New Frontiers missions launched on a 5-year cadence, Dragonfly's original launch date and schedule delays will result in at least a 12-year gap in New Frontier mission launches. Lastly, we have concerns about the likelihood of Dragonfly meeting its cost and schedule baseline. As indicated by APL's Earned Value Management System, a project management tool designed to objectively measure and assess a project's cost and schedule performance, project's cost and schedule performance is poorer than planned. Oh, gee whiz, you think? Further, NASA's Office of the Chief Financial Officer identified potential issues with the accuracy and validity of APL's EVM system and asked the Defense Contractor Management Agency to perform an independent assessment of that system.
Discovery, go at throttle up.
So you have Johns Hopkins, the Johns Hopkins Applied Physics Laboratory saying that this project is not performing, the project schedule performance is performing badly. And NASA's chief financial officer says, no, it's not. I'm going to get the Defense Contract Management Agency to perform an assessment of your system to ensure that it's performing poorly. Never mind the fact that it was supposed to launch next year and now it's not. And it could potentially cause a ripple in New Frontiers missions that could result in over more than a decade between New Frontiers mission announcements. No. I need the Defense Contract Management Agency to make sure. They need to look at it to be sure. Brother, it's supposed to launch next year. Where is it? What rocket is it launching on? Dude, oh my God. Who are these people? Who are these people? Dude? Who are you? Do you care about space at all? Like, not you guys. Like, do these people care about space? Like, dude, that is the... I know Rook said NASA was bad at capital allocation, but gosh darn, this is ridiculous, man. Also, one big red flag that I saw that now that I'm really thinking about it up here. Dragonfly was selected under a New Frontiers announcement of opportunity with an $850 million cost cap on principal investigator managed missions costs. which primarily includes development costs but excludes launch vehicle and post-launch operations costs. They gave out the contract for this thing without a launch vehicle. Big red flag. Big red flag. Who does this? Who are these people, man? What are you doing? Who picks a payload and not the launch vehicle? Oh. And no post-launch operations costs? Nothing? Once it's launched, we just gonna figure that out later? Figure out who does that later? Who launches the lander without its rover? Oh my goodness, what a freaking mess, dude. What a mess. What a mess. If even half of this stuff is true, what a freaking mess. Okay, all right, what we recommend here, this part. My guess is that the OIG is gonna recommend some type of board to oversee this whole thing to make sure that the management, yeah, let's see. They're gonna, let's read it in a second. Would you rather have it the other day where you have a launch vehicle for a dang brick? No, I wouldn't, weather guy. No, the point of this is that I don't want it the other way. I want it the right way. The right way is where you buy the payload and, I don't know, the launch vehicle that it launches on is kind of important to your stakeholder expectations. That's kind of a big deal. Kind of a big deal. First of all, the rocket that launches this needs to be nuclear certified. It needs to be able to be okayed for launching payloads with nuclear capacity. Dragonfly is powered by an RTG, a radioisothermic electric generator. It is a small nuclear power plant. It's not a reactor, it's a nuclear power plant. Differences. It uses radioactive decay of fissile materials to generate heat. And it scavenges that heat through a heat pipe or a heat plate and generates electricity that way. It doesn't generate a lot of electricity, but it generates enough. It's definitely, the thing is, you need plutonium to do that. Oh, I'm sure in 2028, plutonium's going to be available in every corner drugstore. But the problem is it's 2025. NASA, I'm afraid you're stuck here. No. All right. Back to the future side. You need a vehicle that's certified. That is huge. It needs to carry a nuclear certification. You don't have a nuclear certification from the Department of Energy, Nuclear Regulatory Commission, you're not launching on it. You're not launching on it. Atlas is qualified to do this, but there ain't no Atlases ready for this vehicle. All the Atlases are gone. They're all used or bought. So does Vulcan carry this certification? Does Falcon carry this certification? What carries this certification? Picking the launch vehicle when you're launching something with nuclear capability is a very, very, very big deal. That's why not doing that at the beginning of this contract is a huge red flag. Huge red flag. My mom said I'm not allowed to watch when your eyes get this big. Oh, you going all crazy-eyed on me. Crazy eyes. I'll show you them crazy eyes. Let's get busy. No, that's a huge problem. Like, dude, what are you doing? Who makes a payload but no rocket? Who makes a rocket with no payload? I'll tell you who does it. Those guys are pretty damn good at it. What's wild is that APL isn't even trying to milk money like a defense contractor because they can't, as they're a federally funded research center. It's just pure incompetence like that. NASA couldn't even allocate the cost to fork over the launch for this stupid vehicle. And then the operations cost. Who's going to operate this? Who's going to operate it? I'm pretty sure I read that coast is going to take a little while. It's going to get there in what, 2035 or something? What's that, Venturino? You got something for me? NASA awards, this is from November 2024. NASA awards launch services contract for the Dragonfly mission. They selected SpaceX for a Dragonfly mission, a rotorcraft mission in the New Frontiers program designed to explore Saturn's moon, Titan, Firm fixed price contracts valued $256 million, which includes lost services and other related costs. Dragonfly mission carrier has a targeted launch period of July 5th, 2028. Hey, that's my birthday. To July 25th, 2028. On a Falcon Heavy rocket from 39A. Okay, so Falcon Heavy does have this certification. The LSP wouldn't have awarded it if they didn't, so that's good. But, guys, you're missing the point. That doing that at the beginning of the mission is asking for problems. Now, don't get me wrong, NASA has done this in the past, but also at the same time, NASA has done this in the past, but that was 2024. That was last year. It's about a year ago when they awarded SpaceX for this contract, dude. NASA has ordered the design to be refactored 4 times. I'll bet you one of them was for that. Because the only other thing that I know that's launched nuclear-capable NASA civilian payloads is Atlas. Unless I'm wrong. Anybody want to correct me on this one? With this project management, I think it's safe to say that this mission is canceled. Actually, Graham... Sup, you shaved. Yes, I did. Actually, Graham, to be honest, this isn't... it's going to sound screwed up, but this isn't the worst I've ever seen. This isn't the worst. Gateway was the worst. By a long shot. Gateway was the worst. This is not that big of a deal. There's a couple of red flags here and there, but, yeah. I mean, the truth of the matter is, yeah, Viper was definitely up there. The truth of the matter is that right there is one of the most complicated payloads. It's one of the most complicated probes ever devised, by a long shot. That thing is super complicated. It's super complicated. If there was anybody out there that could give me okay, there's a rule in aerospace engineering, okay? There's a rule. Anytime you're doing something you don't know how to do, it's probably going to cost about 3 times as much as you think it's going to cost. Yes, take your cost, times it by pi. That is an unspoken rule in aerospace project management. If it's something complicated. If you're doing something like, I don't know, building a lunar launch vehicle or something, that's not nearly as complicated. I mean, it depends on the launch vehicle, but you get the idea. If you're doing something that's known, something that's off the shelf, that's not as complicated. It's not as big of a deal as you might think. But these new frontiers of opportunity missions are supposed to be pushing the forefront. Could anybody here that's going to sit here and say that something, a freaking Perseverance-style rover with a nuclear power plant on the back, that is basically a cutting-edge Mini Cooper-sized drone that could fly around on the surface of Titan. If anybody could give me an upfront mission cost about that, I'd tell you they would be lying. Because the truth of the matter is that you're not going to know how much this thing is going to cost. You know why? Nobody's ever made a helicopter to work on on Titan. We've made a helicopter. The only other people that's made a helicopter work on another planet is NASA. But that was the Jet Propulsion Laboratory. That was an APL. Differences. If somebody said that this is going to cost this much, this is how much it's going to cost, you're good to go, I would be like, no, you're probably wrong. That's probably not right. Because how the hell do you know how much it costs? Have you built a helicopter to go on Titan? You have not. You can sit there, and the chief financial officer at NASA can sit there, and they can cope and seethe and pretend like they know how much it's going to cost, but they don't know how much it's going to cost. Which is why that part about the CFO is particularly annoying. This part right here. The CFO thinks that John wants a further... You want an independent assessment of the Applied Physics Laboratory's Earned Value Management System. Oh, I want to look more into that because that says the project that I oversee is not performing financially correct. I want to make sure that your system is right. Bro, it's Johns Hopkins APL. Is it... That's like going to the Draper Laboratory at MIT and being like, you guys know nothing about avionics. I want to make sure you know what you're talking about. It's like the Draper Laboratory, the people that designed the Apollo guidance system. Yeah, sure. They know nothing. Yeah, I want to make sure. Okay. Sure. Perseverance had an RTG too. They just changed out the transport mechanism. Well, yeah, of course. Actually, that was MIT. Look up where the Draper Laboratory is, Graham. Look up where that is. You are trying to tell me how school works that I grew up like 3 or 4 miles away from. Try again. Swing and a miss. Buddy, it's the Institute. That's my home turf. You don't mess around with my home turf. You guys with your damn toll roads or whatever. Roll toad. Roll a frog, brother. No. You don't tell me how this works. MIT doesn't have a football team. Harvard does, but they're busy playing Quidditch. I'm not kidding. There are Quidditch courts at Harvard. Yeah, they're on the Charles River. It's weird. Yep. It's strange. Yeah. Yeah. Yeah, I've been driving to Micro Center before and I've seen college kids playing Quidditch. They run around with a broom between their legs. They run around a soccer field. I'm not making this up. I could show you the exact field where I've seen it. True story. It's not a soccer field, dudes. Just saying. Just putting it out there. Yes, Bob. Yeah, something like that. Anyway, what do they recommend? To build upon the effectiveness of NASA project management, increase the likelihood of mission success within the established cost and scheduled commitment, ensure programmatic balance in the future, and ensure compliance with NASA policy to accurately reflect cost and schedule baseline commitments, we recommend the Associate Administrator for the Science Mission Directorate 1. Document lessons learned from the decision to begin Phase C development work prior to establishing a baseline commitment. Update Dragonfly's project plan to reflect baseline commitments. Yeah, updating the project plan to tell people what it is probably going to be useful. Maintain adequate levels of unallocated future expenses to support Dragonfly's project through Phase D. Yeah, just make sure you have more money next time you do that. Okay. 4. Ensure that the Applied Physics Laboratory timely implements any recommendations needed to bring the EVM system into compliance. Yeah, Aquilix, really, it is. Yeah. Document lessons learned from the decision to begin Phase C development. Yeah, here, we need you to write a report on what you did wrong. That's... And 5, ensure the science community is informed of the updates to the expected scope and cadence for New Frontiers mission. Guys, am I being obtuse here, or does that recommendation quite actually just say, well, you have problem A, B, C, and D, and our solution is to fix problem A, B, C, and D? Is that what that says? Am I drunk? Like, well, you had problems A, B, C, and D. Well, there's your problem. Our solution is that you fix that problem. Is that, am I stupid? Is that what that says? I really like number 3. Oh yeah, just make sure you have the money next time, you know. Make sure you have the money next time you get to the next project review. Yeah, okay. I'll do that. You didn't do the minimum, so do the least. I don't figure out what you did wrong and have more money next time to do it right. Am I dumb? Is that what that's? I'm actually asking because that certainly is what it seems like. And I'll admit, I whenever we go into these OIG reports, I carry a heavy negative bias towards NASA, and I just want to make sure I'm actually explaining what's going on here correctly. It very much reads like, do your damn job already. Nothing will change until people get fired. And you guys know what the messed up part is? This isn't the worst OIG report I've ever read. It's actually not bad. That tells me that Dragonfly is probably going to launch when they say it's going to launch now. Probably. I think it's hilarious blaming COVID as your schedule driver, as your primary schedule driver for delay in the year of our Kerbals 2025. I think that's hilarious. But, not that COVID is hilarious. It's blaming the pandemic at this juncture in time. But it very much seems like they didn't get allocated the money to play catch up either. So, nice. Just wait till you hear Jared talk about the X59. I listened to most of that this morning, Hellfish. Does Rook understand that so Jared Isaacman did an interview with, what's the name of the podcast, Hellfish? I forget the name. The guy was a good podcaster, to be honest. Sean Ryan is the guy's name. Yeah. He's actually a pretty damn good interviewer. I was actually very, very, very happy with the questions that he asked. But he all right, hold on. I'll tell you in a second. Sort of, there's a bit of public shaming involved and a bunch of things that are obvious, but they can't not put in the report. It's actually quite familiar from my time in the military, seeing corrections being handed down. It's more effective than it seems, unless the perps are bad enough that you need to build a paper trail on them, which this contributes to. Yeah, I guess I understand that. They got rid of a bunch of staff, but not selectively. Instead, they made it so anyone that felt they had a solid chance to get a new job elsewhere would leave, which gets rid of the exact wrong people to increase productivity in the long term. Green Dragon, what does that say? Remember this, NASA Office of OIG, conclusion, ML2 is a critical part of the infrastructure needed to launch larger variants of the integrated SLS Orion system, beginning with the Artemis 4 mission. Bechtel was initially contracted to design, build, and test ML2 for $383 million and deliver it to NASA by March of 2023. Contract has nearly tripled to $1.1 billion, and the delivery date has been delayed more than 3 years to May of 2026. That's not entirely Bechtel's fault, Green. It's a lot their fault, but it's not entirely their fault. In the case of the ML, but yeah. Anyway, Jared Isaacman went on the Sean Ryan podcast, right? And Hellfish, he talked about the aeronautical stuff, and he tried to make the argument that the current aeronautical projects, particularly the X-59, is a boring thing, and that the XB-1 did the exact same thing and has been retired, which is that's a little bit of a weird thing to say. Boom Supersonic's XB-1 was a supersonic test demonstrator, a civilian-built supersonic airplane. experimental airplane. It was a test demonstrator. NASA's low boom supersonic, the quiet SST, so the X-59, is designed to have an airplane that makes no sonic boom. The reason why is that the plane has this big duck bill of a nose up in front, and that low boom is designed to deflect the sonic boom up, not down. So when the plane is flying, it can fly at Mach 2, and it won't, if you're on the ground, it won't leave a sonic boom because it's designed to make the boom go up. Sonic booms are directional. They're highly directional. Most sound is, like a speaker. It goes in one direction. It radiates out, right? Sonic booms kind of work like that. In that podcast, Jared Isaacman compared the X-59 to the XB-1, which is... That's like comparing an F-4 Phantom to an F-15 because they both can go past Mach 1. Those are two way different airplanes. Yeah, and Boom tested the idea that a sonic boom won't reach the ground. No, dude, that's not the same thing. No. Oh my goodness. That's not the same thing at all. What Boom Supersonic figured out is that when you're in the top of the transonic regime, so Mach 1 to Mach 1.2 to 1.3, somewhere in there, it's somewhere around, 1,000 miles an hour, about 1,600 kph, somewhere in there. If you're flying at a high enough altitude and you stay at Mach 1.1, 1.2, the sound of your sonic boom will not reach the ground. It will not be audible on the ground. That's what they figured out. That is not the same thing as what the X-59 does. The X-59 is designed to travel well past Mach 1. And it's designed to leave no sonic boom. We're not talking about the sonic boom propagating down and not reaching the ground because it actually reverbs back up, which is very strange. That's super cool, actually. The X-59 is just designed to straight push the sonic boom upwards because of its duckbill nose. The X-59 is designed to go way faster than the XB-1, like way faster, and leave no audible sonic boom. Those are way different things, man. Like, I'm sorry, I kind of agree with Rook that NASA should be doing more crazy aeronautical stuff, right? But comparing the XB-1 as a commercial alternative to the X-59 is no. Those are not the same thing. I'm frankly a little bit confused because this guy flies fighter jets around, right? Like, Rook, I love you, dude. What are you talking about? Those aren't the same things at all. Like, what? Why would you say that? Those are not the same. Unless I missed something, right? Jared's point was that Boom was able to design, build, test, and retire their aircraft before the QSST ever got off the ground. The X-59 is like an order of magnitude more complicated in its design than the XB-1. Like, they're supposed to fly this summer. It hasn't. Well, that's reasonable. That I think that Lockheed should do something with it. I'm not sure why they haven't done anything with it. That's fair. I think that's a fair criticism. But to compare it to the XB-1, like, did I miss that? I don't understand what he was getting at there. Like, the fact that commercial can make a plane go Mach 1 faster than NASA can? Buddy, NASA made a plane go Mach 1 in 1948. Like, the X-59 isn't about just making a plane going faster than the speed of sound. The X-59 is about making a plane go Mach 2 and leave no sonic boom. That's huge. That's a huge development, and that development is going to take time. Why would you even compare those two? That is really, I don't necessarily agree with that. Now, once again, that's not to disparage like Rook or anything. I think the vast majority of the stuff that he was saying about capital allocation at NASA was genius. Really good idea. It really pisses me off that they didn't make him the administrator because somebody got butt hurt somewhere. That really pisses me off. Like, that sucks, man. But anyway, that one particular thing, dude, I was like, what are you talking about, dude? That's not the same at all. Like, it's the same thing with what he said about nuclear thermal rockets. He said that nuclear thermal rockets are no good because they sit on their test stand all day, completely overlooking the fact that nuclear thermal rockets exist. They physically exist because they sit on their test stand all day. That means they've been made and they've been built and they work. And then somehow he compared that to nuclear electric, which is something that doesn't work. That is a future technology, and said that nuclear electric is better. A technology that we haven't built yet is better than the one that works currently. That's a very interesting argument to make. He was geek. He was talking about them in the application of mitigating sonic booms, which is why I got really confused, because those are two different things. You're actually comparing a sailboat to a cigarette boat and saying they both float, so why did one take longer to make than the other? Like, what? What? Also, they're sitting on their test stands because some bonehead canceled them. It's weird, right? It folded his issues into NASA using the same old tech in new ways. How is the X-59 doing that at all? That would be my question. Now, don't get me wrong. I agree with Rook. I think what he's saying is right. I don't think barking up the X-59's tree is good, because the X-59 is one of the first planes that's actually trying to push the forefront. That's actually trying to do something different. You know what I mean? Aqualex, you're saying the comparison is like having trouble hearing your music, so you make people be quiet versus making noise-canceling headphones. Yeah, I don't have the thing up, but I don't really understand the context of some of that stuff, but I don't really have permission to show Sean Ryan's podcast either, so I'm not going to. Nuclear thermonuclear electric, both. One now, one later. And Allison 578DX is another fun idea for sound. That yeah. What could go wrong? I know what that is. That's the UDF. I know what that is, but also at the same time, loud. Loud. Turns out when you have a bunch of propellers that are made in a way where they can spin faster than the speed of sound, it makes a lot of little mini sonic booms. And you know what? That noise is not pleasing to the ears. All right? Like, that's a UDF. It's an unducted fan. It's a jet engine that's shooting its the thrust into contra-rotating propellers. UDF was something that came about in like the late 80s. It was a NASA project, and this was looking to increase fuel efficiency. The thing is that when the blade tips go faster than the speed of sound, each one of them breaks the sound barrier. So you just have constant microsonic booms coming off of this thing. Geek, the sound that this dang thing, I've never seen it fly, but I've heard I've heard videos of it flying around. The sound that this thing makes is ridiculous. There is a YouTube video around. Here.
Discovery, go at throttle up.
This unusual-looking jet engine has become the first of a
Hey,
new
Jim.
breed of aircraft power plants to take to the air. Called the unducted fan,
It's
or
my next thing.
UDF, by its manufacturer, General Electric, the engine helped power a Boeing 727 on an early morning test flight August 20th at Mojave Airport in California. It was the first of a series of flights to be conducted by General Electric with participation by Boeing Commercial Airplane Company. The UDF is an example of what's known in the industry as an ultra-bypass engine, or prop fan. It's equipped with two large external fans that rotate in opposite directions. The fans are 11.5 feet in diameter and
Note how they turn the sound down, the background sound. The editor of this video turned the sound down when the thing went by. Just listen. Sound gets louder and then they cut it.
bypass engine, or prop fan. It's equipped with two large external fans
Louder?
that rotate in opposite directions.
Turned it down.
The fans are 11.5 feet in diameter and move a far greater volume of air for a given amount of fuel compared with today's conventional jet engines. That translates into significant fuel savings, which is why Boeing has selected this type of propulsion for its advanced 7J7 airliner due in 1992. The two fans are powered directly by non-geared counter-rotating turbines. The counter-rotating action allows the second fan to straighten the swirl of air caused by the first fan, and that contributes to the engine's efficiency. For the flight tests, one of the 727's three conventional engines was removed and replaced with a new GE power plant. A redesigned strut was used for mounting the engine to the aircraft. The 727 returned to Mojave Airport at the conclusion of the successful test flight. General Electric and Boeing plan to continue flight testing the new engine through November of this year.
Pretty crazy, right? There should be another video of this. Listen.
Basically, a McDonnell Douglas MD-80 airliner, otherwise known as the MD-81.
Sounds like a belt sander, man. It's super efficient, but man, is that thing loud. Wow. It's a jet engine that's blowing its thrust into two contra-rotating turbines, which is, yeah. That's loud, very loud. That's what it sounds like. It sounds like a freaking miter saw. Anyway, yeah, no, that's not a good design. That's superbly freaking loud. I would hate to sit in the back of that plane. Dude, I'm getting a headache just thinking about that, Kenwa. Oh my goodness. Anyway, here, let's go to the next article here. This next one is coming from Ars Technica. This is a Stephen Clark article. He's a writer for Ars Technica. Let's see what he's got here. SpaceX's lesson. Here, I'm going to link this up. Go over there and support ours if you guys can. At least give them some clicks so that the article gets some traffic. I'll link it in both chats. So that's a different engine than I think you think it is. The UDF? I don't... Stephen Clark's okay. RJ, yeah. Stephen Clark's fine. I don't have a problem with him. Yeah, the space reporting's pretty good, Joe. I don't mind it. SpaceX's lesson from the last Starship flight. We need to seal the tiles. SpaceX is targeting an orbital Starship flight with a next-gen vehicle next year. Okay. It has been 2 weeks since SpaceX's last Starship test flight, and engineers have diagnosed issues with its heat shield, identified improvements, and developed a preliminary plan for the next time the ship heads into space. Bill Gerstenmaier A SpaceX executive in charge of build and flight reliability presented the findings Monday at the American Astronautical Society's Glenn Space Technology Symposium in Cleveland. Guys, Bill Gerstenmaier is like probably the foremost expert, not probably. He is the foremost expert on reusing spaceships probably in the entire like Western Hemisphere. Gerst, first of all, ran NASA's Human Exploration Operations Mission Directorate. He ran it. And he's a 30-plus year veteran of the shuttle program. There is not one person out there that's more qualified to talk about reusing stuff than that dude. SpaceX picked him up after Jim Bridenstine fired him in, 2018? Is that the guy who was with Elon last launch? No, that was Bill Riley. Bill Riley's different. Different dude. Bill Gerstenmaier is, yeah, there's not one person better to talk about reusing a spaceship. And he's in charge of flight reliability. He's in charge of, like, Starship. Well, not in charge of Starship, but he's in charge of build and flight reliability. Just listen. Gerst, dude, when Gerst talks, you be quiet. You know what I'm saying? He's one of those guys, like, I'm ready to feed the knowledge into my eye holes. All right. This is a pretty awesome article from what I've been told. Let's see. The rocket lifted off from August 26 on SpaceX's launch pad in Starbase, Texas, just north of the U.S.-Mexico border. It was the 10th full-scale flight of SpaceX's Super Heavy booster and Starship upper stage, combining to form the world's largest rocket. There were a couple of overarching objectives on the August 26 test flight. SpaceX needed to overcome problems with Starship's propulsion and propellant systems that plagued the 3 previous test flights. Then, engineers were hungry for data on Starship's heat shield, an array of thousands of tiles covering the ship's belly as it streaks through the atmosphere during re-entry. Gerst says things went extremely well. A little more than an hour after liftoff, the Starship guided itself into a controlled splashdown in the Indian Ocean northwest of Australia. The ship came within 10 feet, 3 meters, of its targeted splashdown point, near an inflatable buoy in position to record its final descent. Video from the buoy and a drone hovering nearby showed Starship coming in for splashdown, initially falling belly first before lighting 3 of its 6 Raptor engines to flip upright moments before settling into the ocean. But the ship had some battle scars. There was some visible damage to its rear end flaps, and most notably a rusty orange hue that emblazoned down the side of the 171-foot, 52-meter tall vehicle. SpaceX founder Elon Musk, that's Gerst right there. He has an awesome mustache. Just saying. SpaceX founder Elon Musk said the discoloration was caused by the oxidization of metallic heat shield tiles installed to test their durability and performance in comparison to the ship's array of ceramic tiles. Unlike previous Starship flights, Musk said nearly all of the tiles remained on the vehicle from launching through landing. Gerst! Yeah, see? He's watching. Delving into the details. This is the part we want here. Here we go. Gerstenmaier went deeper during his discussion of the Starship test flight on Monday. We were essentially doing a test to see if we could get by with non-ceramic tiles. So we put 3 metal tiles on the side of the ship to see if they would produce adequate heat control, because they would be simpler to manufacture and more durable than the ceramic tiles. Turns out that they're not. Okay. All right. Turns out that they're not. Well, at least you know. The metal tiles didn't work so well. They oxidized extremely nice in the high oxygen environment. So that nice orange color, kind of like a space shuttle external tank color, maybe paying homage to the shuttle program, was created by those 3 little metal tiles up on the top. Can you believe that? Gerstenmaier has a talent for explaining complex technical concepts in a digestible manner. He began his career as an aerospace engineer working on the space shuttle program at NASA in 1977. He rose through the ranks at NASA to become head of all the agency's human spaceflight programs, then joined SpaceX in 2020. That's a way to put that. That's a much nicer way to put it than what I said. Anyway, the experiment with the metallic tiles is emblematic of the way SpaceX is developing Starship. The company's engineers move quickly to make changes and integrate new designs into each test flight. Metallic heat shield tiles aren't a new technology. NASA tested them in labs in the 1970s, but never flew them. It's probably a good reason for that. I think we learned a lot by taking them to flight, and we still had enough protection underneath that they didn't really cause a problem. In most of the tiles, there are fairly large gaps, and that's where we're seeing the heat get through and get underneath. A mastery of Starship's heat shield is vital for the future of the program. The heat shield must be durable for Starship to be rapidly reusable. In Elon Musk's eyes, reflying Starship within 24 hours. Yep. NASA's reusable space shuttle tiles used approximately 24,000 delicate ceramic tiles to protect them from the hottest temperatures of re-entry. But the materials were delicate and damage-prone, requiring refurbishment and touch-ups by hand between missions. That's not the whole story, but yeah, that's good enough to get the point across. Yeah, that's right. SpaceX's Dragon crew capsule has a reusable structure that underlies the heat shield, but the heat shield material itself is only used once. Yeah, SpaceX has what's called an ablator heat shield, guys. The heat shield burning off is actually what's dissipating the energy from re-entry. The heat energy that's generated from atmospheric re-entry, I should say. For Starship, SpaceX needs a heat shield that will stand up to the rigors of spaceflight, intense vibrations during launch, extreme thermal cycles in space, scorching heat of re-entry, and the crush of the launch pad's catch arms at the end of each mission. Musk has called the ship's reusable heat shield the single biggest engineering challenge for the Starship program. Continuing his presentation, Gerst pointed to a patch of white near the top of the heat shield, Starship's heat shield. That part. I'm actually super curious as to what that is. I think it was the silica blankets. I think. Let's see. This, he said, was caused by heat sweeping between the gaps in the tiles and eroding the other underlying material, a thermal barrier derived from the heat shield on SpaceX's Dragon spacecraft. Technicians also intentionally removed some tiles near Starship nose to test the vehicle's response. Yeah, the underlying material, it's the silica blankets. Interesting. It's essentially a white material that sits on Dragon and it ablates away. And when it ablates, it creates this white residue. So what that's showing us is that we're essentially having heat essentially get into that region between the tiles, go underneath the tiles, and this ablative structure is then ablating underneath. So we learned that we need to seal the tiles. Oh, that's not as easy as you might think. Didn't they coat them in deck sealant? The shuttle tiles, yeah. Yeah, pause for a second. Green, the shuttle tiles were more than just, needing to be refurbished. A big problem with the shuttle's tiles is that they were silica-based. They're rocks. It is a very, 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 very porous rock. Rocks are really good at absorbing heat, as we see from like lava and stuff. It's pretty dang. You need a lot of heat to melt a rock, right? Problem with that is that porous rocks are also extremely good at trapping moisture, and that's the problem that they had with the shuttle. The tiles would be fine during re-entry. They'd be all fine and dandy, but the shuttle would come down and land in Florida, a place that is not known for being dry. And the tiles would actually absorb they would pull the humidity out of Florida's humid atmosphere, right? They'd pull the humidity out, and they would have water trapped inside of the tile. And the thing is, they would glue the tiles onto the shuttle. They would glue them on, and the glue is water soluble. The water trapped in the tile would eventually erode the glue, and the tile falls off. That's why the tiles needed to be re-injected. They needed to re-inject the glue into the tiles. That was their solution. Before the tile falls off, if you identify a tile that's like loose or something, you push on it and you put you have a little dot and you have like a cool NASA syringe thing, and you re-inject the adhesive in there. It displaces the water out and it reseals the tile up against the shuttle's hull. That's why if you look at a picture of Discovery, for instance, let's find a picture of Discovery relatively up close here. So here's Discovery. It's at the Smithsonian in Washington, D.C. Here we go. No, I don't want to hear about people want to move it. It's not moving. Don't worry about it. So look, see the tiles right there? See how some of the tiles have dots on them? All these tiles have dots. See that? See all the dots? Some of them don't. Most of them do, though, especially up at the front of the ship here. Those tiles have had that syringe thing, and they've re-injected the adhesive. So if you see a shuttle and you see dots on the tiles, that means those tiles have flown 2 missions at least. If you see a tile with no dot on it, that tile has only flown 1 mission. Any tiles that were on the space shuttle on Discovery that do not have a dot on them were either not re-injected or they flew on Discovery's last mission only. You can see by all the dots on all these tiles here that the shuttle tiles were getting pretty damn reusable by the end of the program. I'm just putting it out there. All those tiles have dots on them, and they all don't. They don't look like they've been replaced in a good minute. I'm just saying. Some of them have definitely been replaced at different times because they're a different shade. The reason why you see some of this gray stuff here is because long story short, the tiles change color. They change color a little bit if they've been through reentry a couple of times. They lose kind of that black sheen. Yeah, they've been used. They scorch a little bit. What doesn't? They painted the shuttle's hull with deck sealer green. I have that on first-hand authority from a guy that did it. From the Atlantis exhibit from KSCVC. They painted the shuttle where they would apply the glue. They painted it with deck sealer and then put the glue on and then put the tile on. So water, if it got past the glue, it wouldn't corrode the aluminum and it would displace it. The glue would help and the water sealer would help displace it. What's that dome made of? That right there is reinforced carbon. It's called RCC. It's a carbon composite nose cone. That is not silicate base. RCC is RCC is basically straight up reusable. Reinforced carbon, so it's a carbon composite, is a kind of, I want to say alloy, but it's not an alloy. RCC is it's like a carbon concoction that is straight up designed to resist reentry heating, like straight up. It is an insane carbon heat sink. The nose of the shuttle is 100% reusable. They never had too many problems with that. Where they did have problems is that right here, your plasma boundary layer during reentry gets really, really close to the bottom of the shuttle. You know, I know. Look at all the scorch marks that are on the landing gear door versus right here. See what I mean? This is how I knew when we saw that picture right there that this is going to be the hottest part. The hottest part of the space shuttle, right there, baby. Right there. That's the hottest part during reentry. That and the wing leading edges. But Starship doesn't have wing leading edges, right? That's the hottest. The other interesting way to tell that part gets the toastiest is that if you look right here, right behind the RCC nose cone, right there, There was a field modification done to the shuttle. There used to be black tiles right there. What they ended up doing is NASA designed an RCC plate to go right there because the tiles were getting scorched right here. They were basically ablating away. They were getting scorched up in there. So a retrofit to the shuttle orbiters that they ended up doing was extending the RCC down here to the landing gear doors because the tiles were, like I said, see how gray these are down here? It gets real hot on the bottom of the shuttle right in this area here, like right there. Not here or here so much, but look at how scorched those are compared to these. See what I'm saying? I wonder if we would see an RCC belly plate on Starship. I know what people are going to ask. Well, if the RCC can straight up resist it, why didn't they just make the whole heat shield out of RCC? It's heavy. It's high mass. That's why they only made the nose cone and the wing leading edges out of RCC. A form-fitting shell on Starship could probably work, Geek, but you'd be better off using unifibrous composite tiles instead of silica tiles. I'm pretty sure that SpaceX is using Tough Rock, but they very much might be using silicate still. I've said they've used Tough Rock in the past, but I don't know. Everybody says they're using silica-based tiles, which is weird. It's carbon fiber with graphite instead of resin. Yeah. Yeah. If you have a high-performance automobile, actually the Wiki article reminded me of this, Lux. If you have a high-performance automobile and it has carbon ceramic rotors, yeah, that's where they got the idea. Because if it can resist 1600 centigrade, it's probably good enough for your car. Yeah, fun fact. I don't know, Green. Based upon the color of the last reentry plasma, it looks like silica base. I saw a strong sodium line in the plasma. Yeah, well, I could have sworn, and once again, I must have been I got Mandela affected here. I could have sworn they were using Tough Rock. They were using unifibrous composite. I could have sworn I heard that somewhere. But I think I finally reached a point where I have so much damn information floating around up here that all of the information is getting fragmented. I don't mean to put out disinformation or say anything wrong. I really try to make it something. I really try to make a lot of the things that I learn something that I memorize. So if somebody asks me a random question about tiles, I know the answer. And I know the answer without looking it up. Do you guys ever notice that whenever I'm giving an explanation, I switch to this camera and I look directly into the camera? You guys have noticed the crazy eyes, but you know why I do that? I do that to show that I know what I'm talking about. I didn't have to look this up. I can remember it off the top of my head. But that hasn't been so much the case lately, so bear with me. I also try to be honest about looking stuff up too. Like if I look something up, I'll look it up on stream. It's to assert dominance. Now what, chat? Now what are you going to do? There's a limit to that, though. There's a reason why we use reference materials. Yeah, Aqualex, and everybody's limit is different. I want to know where my limit is. I think they should experiment with single piece tile sections rather than little tiles with lap joints in between. Lap joints aren't good for hypersonic flow. You don't want tiles overlapping, Bob. Maybe Gerst will talk about it here. If not, I'll explain to you why. Has anything been of significance since the 1900s for space and rockets. I know we have Starship and reusable boosters, but has there been anything comparable to what we have made back then? Reusability, Toasty, and proving out reusability, at least partial reuse with Falcon 9 is a big deal. I know it's easy to write it off and be like, oh, well, other than reusability, if we dude, reusability was something that just 15 years ago people were saying is impossible because of the shuttle program. Manufacturing, the back end, software, those are huge stuff. They're not as easily seen as something like a Saturn V or something. You know what I mean? But reusing any piece of spaceflight hardware 30 times is damn impressive, dude. Thermal protection systems. You know what, plane shifter? That's a really good point. Hey, sorry, I'm just trying to get my question out. Okay. How come Starship doesn't use RCC instead of Tough Rock? It's because it's too high mass, Jackal. I already said that. I saw your question and I said that, but I guess you wanted me to acknowledge you. Hi. No, I said it pretty quick, dude. So if you missed it, yeah, a lot of info comes at you real quick on this stream. That's my bad. I got to get better at doing that. But yeah, RCC, the reason why like this whole shuttle didn't use it or why Starship doesn't do that is because it's really high mass. It's a trade-off. And I'll be 100% honest. This is more EJ's opinion now. I don't think you need RCC on Starship. I really don't think you need that. RCC is too much. Why? Well, the reason why RCC is too, like, you don't need that heavy duty of a reusable heat shield. Starship's made out of stainless, baby. Starship's tiles are not nearly as thick as the space shuttles. The space shuttle's tiles are this thick in some areas. They're like 2 to 3 inches. I have a Starship tile up there. It's about an inch thick. Think about all the mass saved. Now, don't get me wrong. It's always a trade-off. Do you make a super lightweight aluminum orbiter, right, with really thick tiles that are really light that could potentially, come off, right? Or do you make a Starship out of stainless steel? Do you make your reusable vehicle out of stainless, and then you swap some mass, like the steel is definitely higher mass than the aluminum, but your tiles don't need to be as thick. It's always a trade, dude. I think because of the stainless steel, and because I've seen shuttle tiles, and I actually have a Starship tile sitting up on my bookshelf over there, right? They're like an inch thick. SpaceX can afford to make a much thinner tile. They don't need RCC. They really don't. And it sounds like from this article that they induced the this unzippering effect here that happens. So Gerst talked about the ablative blanket that is behind the tiles on Starship, that silica blanket that I'm telling you about. The tile is, there's a blanket, so you have your stainless, and then you have your blanket, and then you have your tile, right? They removed some tiles on purpose. So the silica blanket started ablating, right? And when it started ablating, reentry heat was getting behind the tiles that are next to it. It'll pop off a tile like a pog almost, right? And one tile popping off could make 2 tiles pop off. 2 tiles pop off make 4 tiles pop off. 4 makes 8 pop off. 8 makes 16. You see what I'm saying? That cascading effect, that blatantly, that pretty much did happen on the like the chin, I guess, of Starship. That's called tile unzipping. It was something that was theorized during the shuttle program. Now, thank God that never happened. The closest we came to that happening, what was it, guys? STS-27? And this last part, I could be pulling out of my tail. Once again, it's one of those fragmented things. If I'm remembering correctly, the thickness of the shuttle tiles prevented the plasma from permeating behind the tile, and you did not get an unzippering effect on STS-27. But we very much almost lost Atlantis. Here, look at a picture of it landing. Does that look right to you? Look at the tiles. STS-27, a booster parachute, an SRB parachute pyrotechnic went off before booster separation, and it was basically like a shrapnel grenade going off next to the orbiter's TPS. Not great. It is a miracle that Atlantis survived that. Dude, once again, I'll tell you guys, with Starship, you can clearly lose a bunch of tiles, and it's really not that big of a deal. It'll definitely make it, right? Which is crazy. Once again, that's the trade-off with stainless, right? The shuttle, maybe 4 to 5 tiles. After, if you lose...
Oh, this is space. I'm in space.
You lose any more than that, you're dead. That's gone. You're done. Like this, it will unzip. It didn't unzip, thank God, during STS-27. We almost lost. Dude, it was close. Like, look, some of the... You could see the start of some unzipping going on right there, but it didn't happen. It tanked it, and it's a miracle that Atlantis freaking came back in one piece. Why didn't they abort the flight if the error happened during ascent? Lemon, let me explain it to you like this. The space shuttle has a cutout. It has what's called a blackout window in its ascent. From T-0 to T plus 2 minutes and 30 seconds, there's no way to abort. Now, there are a bunch of abort contingencies that happen after that. Right? The shuttle abort contingency is basically 0 to 230 is nothing. Then you have TAL, which is a transatlantic abort, which means the shuttle gets suborbital and then lands somewhere in Europe, right? After detaching the ET and stuff. There's single engine TAL, 2-engine TAL, right? And then from there, you have AOA, abort once around, which is basically where the shuttle will put itself into a high enough orbit to do one orbit around and then come back and land, right? And then there's ATO. ATO is abort 2 orbit. If you have any problems during the ATO section of the window, the shuttle could basically get itself to a stable enough orbit, right? Basically, if you had like an engine failure or like a single engine failure, you press the ATO, right? You enact ATO, you abort to orbit, you get to a lower orbit, and then you assess what went wrong and you figure out how to do the mission from there, or you figure out how to come back down. After ATO, you have MECO. Once you make it to MECO, you're in space, you're good to go. Here's the thing. These all seem like pretty smart abort contingencies, right? Anything before ATO is basically a death sentence. Yeah, that's the reason. Yeah. The shuttle, after SRB separation, you technically had RTLS, where the shuttle would basically turn around with the external tank, do a boost back, jettison the external tank, and then try to make it back to KSC. I mean, there's that. And then transatlantic crossing, those are basically death sentences. They say return to launch site. They say transatlantic crossing. What most likely is going to happen is that the shuttle is going to have to ditch in the Atlantic Ocean. And you know what, dude? The shuttle doesn't make a good boat. It's not a good boat. It's not even a good plane. And space plane is in the name. So why didn't they abort? Because anything other than an abort to orbit is basically a death sentence. Yeah. Like, a lot of the shuttle's abort contingency procedures were just there to make people feel better. I'm not even kidding. It's like if you're flying an airplane. If you're in an airplane and you take off, you get past V1, you rotate, you get a positive rate, V2, gear up, right? And then you have a double bird strike. What do? You could try to get the plane back to the runway, but any pilot knows that if you try to turn that plane around, you're going to stall and you're going to fall out of the air. So what do? there's no scenario here where you're landing on a runway. Like, look at the Miracle on the Hudson. And that's why it's called the Miracle on the Hudson, because that was a double bird strike right after takeoff. The only real thing to do is crash and hope that people survive. Like, I know that sounds ridiculous, but that's airplanes. That's it, man. You have a total loss of power during ascent, during not principal ascent. I forget what it's called. Like, basically after you take off, and like from 0 to 10,000 feet, you got a bird strike there. You got a really, really big problem. Landed in the Hudson is your solution. Ditch. Like I said, the shuttle has all these abort contingency procedures, but what most likely is going to happen is you're going to ditch. And the shuttle is not a good boat. Let me put it that way. Remember how I said those tiles that are on the shuttle, they're really good at absorbing water? Landed in the water. The shuttle has a bunch of rocks glued to the bottom with it. And guess what? It'll sink like it has a bunch of rocks glued to it. There's really no chance of getting out if you ditch that thing into the water. The solution here, honestly, was to fly the shuttle like this and have the crew jump out the hatch. And then the pilot basically can go out the top windows. Because if you belly the orbiter into the water, you really don't have very long before the shuttle will become a really nice submarine. I mean, this is all abort contingency procedures right in the operator's manual. Which is public, by the way. Yeah. That's why STS-27 just chose to press up into space, because, and this was the thing about the shuttle program. This is the thing. They didn't dial the design in good enough. They never dialed it in good enough to avoid these kind of weird problems from happening during ascent. It happened on STS-27. It happened on what is it, 51F? Challenger's second to last flight had an abort to orbit on it. That happened. It happened on STS-27. Foam strikes got Columbia, which still pisses me off because that was more of a fluke than anything. But I'm telling you, statistically, you could launch another 130 shuttles. You could launch another 130 shuttles. That would never happen. Columbia was a freaking fluke. But that fluke happened because we allowed that fluke to happen because we got lazy. If that makes any sense. Have you been to the Sullenberger Aviation Museum? No, I haven't, Rockets, but it's cool. Super cool. Did they even realize what happened during the launch? No, Phil, they didn't. They didn't realize it. So, we don't know this for sure. Just want to be very clear. We don't know this for sure, but supposedly they somehow got pictures of the thermal protection system on Atlantis. Somehow they got pictures of the bottom of the orbiter. Let your mind wander. I bet you can figure out how they did that. They pointed a spy satellite at it. They pointed a spy satellite at the shuttle when it was going by and took pictures of the bottom. They showed the pictures to the crew, and the captain of that mission was Hoot Gibson, a pretty accomplished pilot and an astronaut. And Hoot Gibson took one look at it and he said, "Well, we're dead. Cool. All right. Say goodnight. Well, we're gonna die. This is great." Yeah, he basically looked at the pictures of the bottom of the orbiter missing tiles. He's like, "Well, we're dead. Sweet. All right, great, cool. I like this plan. I'm happy to be a part of it." Now, once again, they actually made it home, which is, I still don't know how that happened, but the tiles didn't unzip. They don't unzip on the shuttle, but they did unzip on Starship, which brings us back to the article. Little bit of a quick shuttle tangent. Sorry about that. I hope it was informative and stimulating. Yeah, Colex. Yeah, that would have been a smart thing to do. Just saying. Chris B would be proud.
Houston,
Honk.
Tranquility Base here. The Eagle has landed.
Why do bakers always try to make bread efficiently? Because it is the path of yeast resistance.
All right. Yeah. Chris B. Oh yeah. I don't think Chris. Do you guys think Chris B knows the extent of the shuttle knowledge floating around up here? I don't think he does, dude. I gotta talk with Chris B about this stuff sometime. We gotta make that happen. I don't know if I could do it on a shuttle Sunday or something on NSF, but I don't think he realizes how much I know about that damn thing. Probably not. He seems like he's sane, though. He knows a lot about the space shuttle, dude. You know, I'm not saying I know more than him. In fact, I think he knows more than I do about the space shuttle. But also, yeah, Chris B knows a lot. I don't know, man. I think when our powers combine, we could form the all-knowing encyclopedia of shuttle. You didn't know about the pitot tube. Dude, the thing has a million freaking moving parts. What do you think? I know every nut and bolt? Kiss my butt. How about that? How about that? Yeah, he's a clown. Hey, enjoy your weekend. Great, great. Enjoy your night. I hate that clown. Does shuttle have 1-ply or 2-ply toilet paper? Guitars, I'm going to guess 1-ply. And the reason why I'm going to guess 1-ply is probably because it's lower mass. But I don't know for sure. Every conversation about space, about human spaceflight, always devolves into how the toilet works. It is inevitable. On a long enough timeline, someone's going to make a fart joke and talk about the toilet. It happens every crew launch, dude. Every crew launch that I've ever covered on this stream, period, full stop, someone asks about how they poop in space. If the DoD was involved, it's 1-ply. Oh, that just sounds terribly uncomfortable. The toilet is the most important part, though. But lowest bidder, dude. What are you going to do? Fun fact, the derivative of the shuttle's toilet is the toilet that they use on the ISS. Yeah. Why reinvent the wheel? Made sense at the time. Do you still have the shuttle's manual? Yeah, of course. Petrie. Nice. Hey, Jay, I just want you to know I really needed a nerd tonight, as I am a boring nerd and the family is out without you. Dude. Petrie, enjoy the peace and quiet, my dude. Hear that? That is the sounds of peace. And maybe Starbase. He has a shuttle's manual. It's thicker than the Bible. Yeah. Yeah, Louiso. It's quite large.
Houston, Tranquility Base here. The Eagle has landed.
Why couldn't the astronauts use the toilet on the shuttle? They forgot to ply the toilet paper.
Okay, cool. Let's see how our station wagons post is doing. 23 replies, 7 retweets, 106 likes. All right. Tyler says the ones with the Corvette engines in the back seats that faces backwards. Yes! Max says, say it loud. Say it louder! Anthony says Anthony's the guy that runs Rocket Ranch. Rocket Ranch is awesome. That guy's cool. Estates in general are the best IMO. Your favorite vehicle? It's a Beamer, but I'll still give it a like. Goalie. Okay, so 1, bite me. 2, that doesn't look bad, dude. Like, not the wood trim, the station wagon part. Not the wood trim. Screw the wood trim. The station wagon part looks pretty good. That's pretty cool. Have you ever considered a satisfactory stream? You could say that. Yeah, get rid of the wood trim. You know what this thing needs? This thing needs like a stripe down the side, right there. See that? Like a white stripe or something. And it needs to be like yellow or something. I don't know. The Dodge Magnum was an underrated station wagon. It's essentially a Mercedes E-Series wagon, Phyllis. But yes, I agree. You'd rather the Truckla? EJ'd hate you. I just bought a Model 3. I don't. Why would I hate you? I don't mind Model 3s. If you want to buy a Model 3, that's totally cool. I don't have problems with Model 3s. I think those are neat cars. Great commuter vehicle. So ain't nothing wrong with a Model 3. Your 2-vehicle garage is a Model 3 and a Tundra. Well, I'm sorry that you hate America, Ephemeral. That's fine. Not the Tesla part. The other part. I'm sorry. What? I'm sorry that you hate America. You're going to start speaking Chinese here, too? This is a joke. I know that Toyota's Japanese. It's a joke. It's un-American, man. Still joking. Some people probably took it wrong, but hey, whatever. You know, that's just out there on the internet now. That's fine. Ain't the Tundra made in Texas? Yeah, so? That's the hardest cope I've ever heard. Who owns the damn company? Oh, wow, the foreign cars are made with more American parts than the American car. It's not about the freaking car and where it's made. It's about who owns the damn company, you dopes. Well, it uses the American part. Anyway. The primary structure for Starship is made of a special alloy of stainless steel. Most other spacecraft designed for re-entry, like the Space Shuttle and Dragon, are made of aluminum. The steel's higher melting point makes Starship more forgiving of heat shield damage than the shuttle. Engineers observed several more white blotches. What are you looking at me like that? Stop it. I'm trying to read. I'm sorry, that's funny. What is wrong with you? I don't know, man. I don't know. Reed, I'm trying. They're looking at me funny, man. What do you want? Yeah, Cody. What a bunch of cope, whatever. Anyway, do you think Flight 11 will go orbital? Probably not, Amadeo. Anyway. Engineers observed several more white blotches lower on Starship, where heat also leaked between the tiles and burned the metal underneath. Several more white blotches lower on Starship. Yeah, you got some right there, but I do believe that that's where tiles were removed from. Previewing Flight 11. Not great, but SpaceX officials think they have a solution. Put all the tiles on, perhaps? Near the top of the ship, amid the patch of white, engineers noticed a few darker areas. These are places where SpaceX's ground team installed a new experimental material around and under the tiles. Looks like right on the center right there. We call it crunch wrap. It's like wrapping paper that goes around each tile, and then these tiles are mechanically held in place. They're snapped in by a robot. When we push the tile in, this little wrapping paper essentially sits around the sides of each one of the tiles, and then we cut it off the surface. I'm not making the joke. I'm not doing it. I'm not doing it. Nope. I ain't doing it. I'm not, nope. So they're using that, they're filling the gaps between the tiles. I get it, because he talked about tile gaps a little bit earlier. This crunch wrap material could seal the spaces between the tiles without using gap filler. The gap fillers on the space shuttle added complexity to the heat shield, and they sometimes dislodged in flight. Yeah. This is kind of what we're going to fly on this next flight, on Flight 11. When we fly here, we're going to put essentially crunch wrap everywhere and see if we can get better sealing and better tile performance moving forward. These are areas where we're inventing things. We're doing test experiments. We're doing test envelope expansion. We're doing aerodynamic things. All of these things are critical. Cool. Remind me to tell you guys about gap filler and why that's a pain in the butt. I'll tell you in a second. For Flight 11, Starship will fly on a suborbital trajectory similar to the flight profile the ship has flown on all of its missions to date. The next flight could happen in October and will prepare SpaceX for the debut of an upgraded Starship Super Heavy rocket next year. SpaceX test fired the Super Heavy booster for the next launch last Sunday in Texas. Yep, there it is. This type of crunch wrap. Okay. They already did steak. The next what if is if a Taco Bell crunch wrap re-entered the atmosphere. They already did steak. Yeah, I agree, Rocket Guy. Is it supreme? Why, dude? Why you gotta make that joke? What are those two things in Booster 15's inner stage? Those things? Catching the thing can bend the top. They put braces in there to make sure that it's concentric. Don't worry, that gets fixed with Block 3's design. Mitigations, remember, until the fix comes down the pipeline. I prefer Gordita, yeah. Yeah, those are braces, because when they first caught Booster 12, like if we're looking at it from the top, it basically did that. It basically did this when it got caught. It turns out holding up a rocket from the sides is a little strange. They did something. There's a pretty good way to solve that problem, SpaceX. I'm just saying the shuttle program did a pretty good job with the internal stringer in the inner tank on the external tank. I'm just saying. But if I had to guess, that's probably what's holding the grid fins together in the Block 3 booster design. Huge guess, though. Huge guess. I'll talk more about that in a second. Let's finish the article. And gap filler, too. I think this next flight, we won't push quite so many different techniques in. We're going to try to go more towards the configuration we want to go fly next year. Yeah, so it's going to be a Block 3 heat shield. Got it. That umbilical looks like Doc Ock. It definitely does, dude. Crazy thing is, it can move around. It's on hydraulics, so it can actually, the thing can translate and go forward and back. That's how it automatically docks to Starship, which is super cool. I mean, even that, dude, that's pretty crazy that the thing, they can just move the ship quick disconnect into place, and the umbilical will locate itself on Starship's carrier umbilical and just secure it in. That's pretty damn cool, actually. That is a trick piece of tech in its own right. Yeah, the umbilical connects itself. The stack builds itself. It's the same with Super Heavy, by the way. They stack Super Heavy, they open the BQD hood, and then just the thing pops out like Punxsutawney Phil coming out of the freaking hole and just whoop, locks in. Does it automatically. Yeah, that's pretty neat. I mean, dude, I'm just pointing it out there. It's pretty good. Going to orbit next year. Next year, we step up to another version of both ship and booster called V3. It also has a new Raptor engine underneath with more performance than the previous ones. So we'll fly V3 suborbital first, and then if that's successful, we'll probably go orbital after that with the next V3. That would mean an orbital flight no sooner than Flight 13. This matches a recent comment by Elon, who said SpaceX will attempt to catch and recover Starship back at Starbase somewhere around Flight 13 to 15, depending on the outcomes of the next couple of test flights. It also agrees with predictions from my colleague, Eric Berger, in a recent story on Starship. It's not a prediction if they tell you what they're going to do. Sorry. Too far? Just saying. To attempt to catch, SpaceX must accelerate to orbital velocity, fly all the way around the world, and come back to Texas. Yeah, that abort once around thing, Levin, that I was just talking about with the shuttle, they got to do that. That was before. Before what? What are you talking about, man? Eric Berger has sources out the tailpipe, dude. He gets privileged information way before anybody else does. It's not a prediction if they tell you. What are you talking about? It's not a prediction if they tell you all the damn answers. It ain't a prediction. That's just you citing an anonymous source, which he does all the time. What is this, controversial? It ain't controversial. You can make a prediction. You make no predictions. What are you talking about? Did the new Centaura launch scrub again? No, it's scheduled for 9/17 currently. I sense cope. What? Cope? I didn't realize what I said was controversial. Anyway, all of Starship's test flights so far have been suborbital, meaning they come back to Earth before circumnavigating the planet. SpaceX wants to make sure it control when and where the ship comes back to Earth before orbiting the vehicle. An uncontrolled re-entry of a vehicle as large as Starship would result in chunks of debris falling all over the ground. Yep. Orbital missions will unlock the next phase of Starship's development. Recovering Starship in one piece will allow engineers to get a better handle on the performance of the ship's heat shield, among other things. Going to orbit with Starship will allow SpaceX to begin launching more powerful next-generation Starlink broadband satellites for the company's consumer internet service. And now we know it's direct-to-cell as well. Most importantly, for future flights to the Moon and Mars, orbital flight will pave the way for SpaceX to bring two ships together in space for the first demonstration of large-scale orbital refueling. We're going to try to do that next year. In 2026, that'll be the focus to get large-scale propellant transfer. If we're going to leave Earth orbit, we're going to need prop transfer. Yep, 1, 2, and 3. Those are the three metallic tiles right there. And you can see they were testing some different types of gap filler going on there. Gerstenmaier also briefly mentioned the results of experiments with Super Heavy on the most recent flight. On this flight, the booster splashed down in the Gulf, just off the Texas coastline after propelling Starship towards space. SpaceX used the flight to push the booster through higher stresses as it came back to Earth, guiding the rocket to a water landing in the Gulf instead of returning it to the launch pad for a catch by the tower's mechanical arms. What we're doing is we're looking at the angle of attack and looking at how well the booster could fly itself to understand how much ability we had to get it back to the tower in the future. Long story short, if the booster can fly, if it can take a steeper angle of attack and actually work towards more flying than coming straight down, right? That means more of Super Heavy can be used to go up and not down. Because the longer your flight time, if you're flying more horizontally in the air, right? Your descent rate is going to be lower. And if your descent rate's lower, that's more time in the air, that's more drag, that's more time to slow down. So your landing burn doesn't need to be as long. Save a ton of fuel doing that. You'd be surprised. If they can get it so Super Heavy loiters enough time in the atmosphere to get it to at least terminal velocity, you could save a lot of fuel. More fuel can be used to focus on pushing stuff up and not necessarily coming back down. Cool. SpaceX engineers noticed the booster's performance on descent in flight doesn't match the predictions from the computer models or wind tunnel tests. In ground experiments, the booster encounters unstable buffeting as it slows below the speed of sound. Huh. Also takes fuel off the boost back burn. Correct. Yeah, Dead Scum, we'll see. Based on those results, we should not be able to do what we do with our maneuver coming back with the booster, but we've been able to essentially show through flight that we had more stability than either CFD or the wind tunnel show that we have. That's just bad analysis. Well, I'm pretty sure with booster flight, that problem got corrected pretty quick. Yeah, that's pretty interesting. I mean, it's not necessarily bad analysis. SpaceX is probably being very conservative after their last booster exploded when they tried to fly it. The Flight 9 Super Heavy, they tried to, so if this bottle is super heavy and it's coming back down, they basically did this. And look at what happens to the propellants inside when you're flying like this. If you have a downcomer inside of this thing, right, and you try to light the engines right now, half of it isn't submerged. Like, look at how it's submerged in the water, right? Basically, they went to fire the engines and the thing did that. Not great. That's why it popped. It's very, they're very conservative in their CFD and wind tunnel testing. That's pretty interesting. I mean, I'll be honest, it's probably how to do it, but especially after the last one exploded. So the big question of the research community is, why are we seeing these differences? We had an inkling that it would be there, but we weren't 100% sure, and we were able to do that extremely well. Gerstenmaier suggested that a question best posed to universities and government labs. Companies like SpaceX innovate fast, but once they find a workable solution, they move on to something else. I get what I call a minimum viable solution. I don't really understand why it works, but somehow it works. So we're going to use it, and we're going to monetize it, and we're going to make it work. You have the chance to help me understand why it works, and you may find out, hey, there's another approach that actually lets it work even better. If only they let that melon farmer do that during the shuttle program, man, the shuttle would be very good. Startup life in a nutshell. Yep. Two things to talk about. Tile gaps. Why are they trying to fill the gaps in between the tiles? Okay. Short story with tiles. If you look at the tiles on the shuttle or on Starship, you notice there's a little space in between them, right? There's a space in between those tiles, okay? You have to find something that's going to fill that gap, but you can't fill that gap up completely.
Discovery, go at throttle up.
Why? Well, the tiles are great at absorbing heat. Just like anything else, when they absorb heat, they expand, okay? You have to find something that's going to fill that gap when the tiles are at peak expansion, because when they expand, the tiles basically form a phalanx of a heat shield. They butt up against each other. If you don't get that right, if you don't get your gap filler right, they're going to expand, and you're either going to have too much of a gap, right? Or they're going to butt up against each other and try to overlap and pop off. Gap filler is huge. That has to be right. It has to be perfect. And keep in mind, the rate of expansion can be different on different parts of the ship. So the gaps between the tiles might be a little different on the nose than they are on the belly of Starship. Hey, Ellisers, 13-month resub. Silicone rubber will ablate off is the end of that sentence. And remember, if one pops up over the other one, right? If it does that and they overlap and it pops it off, now your plasma is getting underneath the next tile and it'll pop that one off too. And then it'll pop off 2 more and it'll pop off 3 more and then 5 more and then 10 more and then 50 more. That's, once again, that's called tile unzipping. So it's very important to get that gap right. It has to be right. If it's not right, it won't work. Or it'll ablate the tile. Like, that happens. Now, that's the other reason why you don't want overlap with tiles. That's causing turbulent hypersonic flow over your tiles, which basically, if you have a tile over another tile, plasma is going to go by and then it's going to turn down into the next tile. And you're basically vectoring the plasma right into a gap if you do something like that. That's why when you look, when we've looked at starships in the past, right, the tiles have to be smooth, right? So let's look at this picture. See how all these are basically nice and smooth? There might be 1 or 2 that are you get a slight bit of overlapping right there. This is overlapping because these hexagonal tiles are on a concave surface. They're on the belly, right? Those don't seem to have too much of a problem, but even something like that could cause you issues. This is not in a particularly hot area of Starship, right? I mean, yeah, it kind of is. This is on the center line. I mean, the nose is what's going to get the hottest, or the chin, so to speak, of Starship. Those tiles were the tiles from that picture are basically right there. So they did hold up. They did hold up pretty dang well. The crunch wrap is this stuff right here, if I'm understanding this right. The crunch wrap stuff is right up there at the nose. Tom, 52-month resub. What about doing something like with gapless piston rings? The problem is if you're doing it with any type of metal, it's going to ablate. Would love to know how they decided to scale the tiles going up. Was a nightmare for you. Tiles are tricky, food. I'm fascinated by them, but they are frigging tricky, dude. One chink in the armor and... Well, clearly with Starship, that ain't a big deal. Clearly you can have multiple holes in it and it just doesn't care. Like dude, look at this thing. Look, dude, look the freaking back of the wing's missing. And part of the engine section is just gone. It doesn't care. It landed within a 3 meter deviance from space. Like, it clearly doesn't care, but also, yeah, the thermal protection systems are tricky. They definitely had some nasty unzipping going on up here. Will you be covering the Falcon 9 launch? What's a Falcon 9? I don't know what that is. Of course, man. Of course, man. Of course I'm going to cover that. Why wouldn't I cover that? But I do believe it's in about an hour. Not sure if someone has asked this, but do you think the first ship catch will be performed with the old pad to protect the new pad in case of a mishap? Possible. It's possible. You're gonna need 2, AFMEC, right? You're gonna need 2. Like, that's just being smart. For whatever mission does that, catch that super heavy and go. But another thing to consider, another thing to kind of consider is, what if they're doing construction on pad A? What if they're demolishing it? What do you do then? Do you try to land Starship over a damn construction site? I mean, the whole pad's a construction site at this point, so really it's not that big of a deal, right? But, so say you do catch it on pad A, right there. Where are you putting it down? There's no, like, you're going to have to leave the area where you integrate open while you're demolishing the pedestal, right? So another interesting thing to contemplate when it comes to this stuff is So Starship launching from Boca Chica, if you launch due east, the corridor that basically they've been flying, where you kind of go south of Florida and you fly over the Turks and Caicos, right? In one piece, hopefully. If they fly on that trajectory and they stay on that trajectory, it's not going to do a once around orbit unless Starship, unless I'm vastly underestimating the cross range capability of Starship here. It's going to need to do a couple of orbits around. So what they might do, get super heavy, right? Bring it down, turn it over, put it right on that pedestal, get super heavy away, and then prep pad 2 for a catch. A catch isn't going to happen in 90 minutes, if I'm understanding the trajectory correctly. So that means Starship Flight 11 will be longer down the road due to installing the crunch wrap. I don't think it's going to be that long. Ship 38 had a lot of TPS on it already, Evan. I have to wonder if we're going to see them test the printed titanium tiles. As much as you want to, dude, I don't think they are. I think they basically nixed metallic tiles, but I mean, they're always trying new things, so. We know they tested iron-based tiles from the deposit. Well, I mean, steel, but yeah, iron-based. Yeah. Okay, I got you. But I don't think they've tried other things. With printed titanium, you could do interesting insulating structures inside of the body itself, especially if they give it a thin electroplated coat of tungsten or something like that. We might be able to get something rather interesting. You could even do things like labyrinth seals between the tiles. Dude, you want my honest opinion? I think there's more than one way to skin a cat. That might be a good way to do it. Oglex, I refuse to believe that making a fully reusable heat shield is impossible, and I think we're on the same page there. Today, the Udvar Hazy Center announced plans for a 44,000 square foot expansion to its Boeing aviation hangar. Cool. I want to see the blueprint. Oh, wow. Cool, man. They're going to expand the hangar. Dude, that museum is already so freaking good, dude. Great. That's cool. What do you think the chances of them are trying orbit for Flight 11? Look, I've come up with all these crazy theories, Cheeseburger, for what the, sending Ship 38 or orbiting Flight 11. When somebody asked me right after Flight 10, what's my thoughts for the next flight, repeat the exact same thing. Do the same thing over again. Do the same flight trajectory as 10, and Gerst pretty much confirmed it in that interview with ours. Have you been to the Museum of the USAF in Dayton? No, I've never been there. We need to fix that. Yeah. Oh yeah, we need to fix that. That's absolutely, yeah, no, I need to go there. I need to see an XB-70 or the XB-70. There used to be two of those, not anymore. So, one product, what do they want to put in here? Some artifacts of the museum collections that are planned for display after the expansion are the B-17 Shoo Baby. Cool! Shoo Baby! That's awesome. Previously mentioned Flak Bait. Flak Bait, I believe, it's a B-26. There we go. Both of which have never been displayed at the center fully assembled. Others will include the Sikorsky JRS-1, a Pearl Harbor survivor. Dude. The de Havilland DH-98 Mosquito. Oh, my favorite. Hi, Zing. How are you? De Havilland Mosquito. And the Franklin Texaco Eaglet. The museum expects to receive new acquisitions that will also go on display prior to the construction completion. Oh, shoe baby, flak bait, and a mosquito. Now we're talking. Mosquito is one of my favorite planes from World War II, man. And the JRS-1. It's not one of my favorite planes, but that's damn cool that that's a Pearl Harbor survivor. JRS-1 is the only aircraft in the collection in Virginia that was stationed at Pearl Harbor. There's flak bait. Yeah, flak bait's in pieces. You could tell because of the way it is. If you guys have never been to the Smithsonian Annex, it is unreal. That is plain heaven. Dude, there's a space shuttle there. That's kind of cool. Space Shuttle Discovery is there. An SR-71 is there. Here, I'll just rattle off planes. You guys tell me if you like these. The Boeing 367-80, the 707 prototype that did a barrel roll on its test flight. Tex Johnson is there. The Enola Gay, the plane that dropped Little Boy on Hiroshima, is there. A Concorde is there. The only surviving Irado 234 from the Luftwaffe is there. There's no other AR-234 in existence. They have a Horton 229 in there, I'm pretty sure, as well. It's serial number 4. It's not on display, but it's there. That was the German prototype flying wing that the Horton brothers came up with. The F-14 that inspired Top Gun, that shot down 2 MiGs, I think over Lebanon, I think. I don't remember. That's there. They have a couple of MiGs there. There's an F-4 Phantom. I mean, we're not even scratching the surface. There's like 500 planes there. This is the Udvar Hazy Center. Yeah. There's a Ford Trimotor. I'm actually pretty sure there's a Ford Trimotor. I think there's a Junkers Ju-52 there. There's a Focke-Wulf 190, BF 109, P-51C, P-51D, P-47, P-38, P-40. What else is there? They're adding a mosquito to the collection. That's pretty cool. Oshkosh next year. Let's go. Yeah. Like here, I'll show you where it is. It's at Dulles Airport. It's just outside of Washington, D.C. It's over here. It is freaking gigantic. It is a monster of a museum. And the expansion that they're going to do is over here. They're going to expand the hangar down this way, from what I could just see. No Corsair. I ain't going. There's a Corsair hanging in the front door, by the way. Dude, there's so much crazy stuff in there. Like, seriously, look at this picture. There's planes hanging from the freaking ceiling. There's the 367-80. There's Concorde. I think that's a Ju-52. I think. It's just all kinds of crazy stuff in there. There's a 377 Stratocruiser, which is right there. That's a B-29 passenger plane. Or no, that's not a 377. It can't be a 377. It's a tricycle. That's a B-17 passenger plane. I forget the variant of that. You could do the street view. Okay, just for 1 second. We have some time to burn before the launch. Why does this Google Earth on this computer do that? It's a Boeing 307. Thank you. That's what it is. Yes. Really? Why does it do this? What, am I not dragging it on the damn street? Just got back. What are we looking at it in? Can I go? Yes, this is a public museum. This is the Smithsonian Institute, dude. Oh. What? Why does this suck? Oh, there we go. There we go. I got it. 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 Come on. No, no, no. Come on. Go forward. Yeah, there you go. Come on. You know you want to. You know you want to. User error. You shut your fat mouth. Zing. Did I tell you? What did I tell you? What did I tell you? See? Dude, look at what's in the picture. Discovery, an SR-71, P-51C, F-4U. Look over there. Look at that. There's an F-105, F-4, a couple of MiGs over there. There's the F-14. There's a F-8 Crusader or an A-7. There's a UH-1, AH-1 over there. There's a Dauntless sitting down there. Just in the corner. It's just Dauntless, whatever. P-40? No, it's a P-51C. Oh, no, that is a P-40. They must have changed it. No, wait a minute. Hold on. Yeah, that's a P-40. There used to be a P-51C there, I thought. I could have sworn, dude. My brain's going, dude. That's not good. Yeah, the F-105. Look at how big that freaking plane is, dude. F-105's a beast. You're hopping the rail and getting in the pilot seat of that Corsair. I wouldn't do that. But, you know. Getting old, yeah. So, if you can zoom in, see over there? See that plane with the 3 propeller? That's a Dornier DO-335. That's the only one in existence. The Dornier DO-335 was a Luftwaffe plane that had a backwards-facing engine and a forward-facing engine. It's the only prototype in existence. And the Arado 234 that's right next to it, you can see its vertical stabilizer back there, the one, you know, the one with the swastika on it. All the planes are painted period correct. So that one right there, only one in existence. The Arado was a twin-engine jet bomber that Nazi Germany employed towards the end of the war. They didn't make it enough to really have it make any difference, but yeah, push puller, dude. There's engines at the front and the back. Super cool. The LL in the top. Oh, lower level. Thanks, man. I am just in an airplane. What are we? I don't want to be here. Get me out of here. Why am I next to this MiG? I don't want to be next to this MiG. Get this piece of crap out of here. How are we stuck here? Damn it. I want to be next to that. Lower level. Yes. Let's see, what do we got here? Allison 1710 right there. That's the P-40's engine and the P-38. There's the guy. Packard Merlin 1650-7. That's a Spitfire motor. And the P-51D, for what it's worth. Oh, yeah. It's good stuff, man. Cyclones. What else we got? Oh, there's so much good stuff. This is ridiculous, dude. Hey, a Super Saber. Cool. That wasn't there last time I was here. At least I don't think. Cool. F-100. It's Snooper. So that's a CH-46 right there. That's a UH-1, so it's a Huey. What do we got over here? Oh, dude, there's so much stuff here. Unbelievable. That's a AH-1 Cobra. So the UH-1 and the AH-1 basically have the exact same rotor and drive mechanism. It's just this has 2 seats and gun pods, and that one has 2 seats and human pods. It's true. Oh, look at that, an SA-2. You got a freaking SAM. I mean, it's only the trailer. That's not the launcher, but that's a Soviet SAM. There's an F-105. The F-105 is a bomber. A big bomber. Yeah, the Thunder Chief. Big old plane. Dude, that thing can carry... The F-105, dudes, can carry more... It has more payload capacity than a B-17 from World War II. Like, F-105s are no joke. They're pretty stout airplane, from what I understand. Weather at the Cape is still green. Cool. Oh, just the SR-71. No big deal. Whatever. So when do they get a Starship? I hope soon. The Luftwaffe stuff, though, is pretty nuts to me, dude. There's a P-61, a Black Widow. That thing is super rare. The P-61, guys, is a night fighter. That was a night fighter that was made during World War II. That's why it's painted black. That is an extremely rare airplane. They did not make many of those. And there's not many survivors either. Still got the acid fighter by the shuttle entrance? Yeah, the Me-163. Comet. That thing. Yeah. T-Stoff. Hypergalls. So the Germans were... the Germans had that thing. So that is a throttleable hypergolic engine. I think it's T-Stoff. It could be C-Stoff. What's that yellow wing? Kai Fox, that's a Northrop experimental flying wing. So that's an Me-163 right there. That is, so the Germans were getting bombed pretty badly, and they needed a solution to be able to try and to get up there really quick, shoot down a lot of bombers, and then come right back down without being seen. So some crazy German engineer came up with the idea of putting a throttleable hypergolic rocket engine in a fuel tank with a seat attached to the front and a cannon. And this thing, they launched it, not exactly like a rocket. It has tricycle landing gear, and the landing gear actually jettisons. There's a ski under there. So you launch it, the gear falls off, and this thing can get up to like 30,000 feet like that because it's a freaking rocket. And then, you run out of fuel, right? And then you basically dive bomb the bomber formations, and you're going so fast that they're not even going to see you coming. Just bye-bye, boom, blow a bomber out of the sky, come back down and land. It's called that in kind of modern warfare is an interceptor role. So that's a prototype interceptor. The MiG-21 that we saw over there, that's an interceptor too. In fact, most MiGs are interceptors. They're designed to shoot down B-52s. That's the whole idea. Yeah, you have to have balls of steel to want to drive one of those, fly one of those things. There's the Dornier. Look at that freaking thing, dude. Engines in the front and the back. That's the only one in existence, man. It was lifted by the U.S. out of Nazi Germany after the Germans surrendered. There's only one. Look at that damn thing. Two engines, one in the front, one in the back. You got a propeller up front, propeller in the back. Thing is nuts, dude. Yeah, that's a German, that was a Luftwaffe experimental fighter. It's a Dornier Do-335. There's only one in existence. That's it. You're never seeing that plane anywhere else. Oh, yeah. See that thing right there? That's the MXY-7. It's the Oka. The Japanese were experimenting with cruise missiles at the end of World War II. The problem is that this cruise missile has a biological computer inside of it, meaning someone's flying it. Also has a rocket engine attached to the back. Yeah. Desperation is a stinky cologne, chat. This is all the Imperial Japanese stuff over here. There's a 0 somewhere down there. But there's the Arado. Look at that thing. Holy balls, dude. Twin engine bomber with JATO. JATO with parachutes. Pretty cool, huh? J7W1 next to it. Where? That's the only one in existence. The Germans tried to use this as a bomber and it came too late in the war. So what they ended up doing is using this thing as a night fighter. And it was disgustingly good at night fighting. The canopy afforded you insane visibility, dudes. You sit in it basically like this, and you can see everything inside of it. Look at the canopy. Does that look like something out of World War II? That ain't something. That's not something out of World War II. Look at it. Perspex canopy in World War II. That's a jet fighter. That's a jet fighter canopy. Crazy, right? So what they did was, because you had great visibility in here, they installed a radar array on the front. Weird, huh? For night fighting, so it could detect stuff at night. The night fighter Arado 234, I think they called it the Nachtjäger, which is night fighter. It was disgusting, really, really good, but they didn't build enough of them. That float plane was mentioned to be launched from subs. Cool. I know pretty much everything here has been repainted. That stuff hasn't. What makes this pretty special and rare is the insignia, especially on the German one. Everything is painted in the correct livery that it should be in. So I prefer the historical accuracy, man. It's important to understand why these planes are here. That's absurdly important. These planes are here for a reason. Because the people that believed in this nonsense, we wiped them off the face of the earth. I mean, Soviets did too, but oops. I'm not sorry. Are you sorry? I ain't sorry. Frick you. I want your plane as a war prize. Biatch. Focke-Wulf 190. Good fighter. So no pink Nazi planes? Good to know. Yeah. Yeah. Focke-Wulf's a great plane. Really, really smart. Another crazy thing. Like, so if you look at a Focke-Wulf 190, right? Look where the wing is. That's important to understand. Wherever the biggest wing is on the plane is usually where your center of gravity is, right? The landing gear is another dead giveaway. The center of gravity is way up here in front of the cockpit. Okay? Now, why is that a big deal? Well, that's a big deal because having the center of gravity on a propeller aircraft being like way up in the front, affords you insane turning capability. Now, why? Why would it be like that? Because if your center of gravity is all the way up at the front, your control surfaces are all the way at the back. It's straight leverage here. That's called control moment, right? 5 degrees of deflection when your center of gravity is that far away from your control surface is going to make you outturn everybody. So the Focke-Wulf's very smart design in that regard, because your center of gravity is so far forward. Look at how far that wing is forward relative to the cockpit. It's a very smart thing to do. This thing could outturn people. So if you're in a dogfight, you can turn harder than the other guy. The reason why is, once again, because you have great control moment, because your control surfaces are far away from your center of gravity. A little bit of deflection is going to get you a lot of turning there. It's a very, very fast, very maneuverable plane. Pain in the butt to fight against. I mean, the P-47 over there is kind of doing the same thing, right? I mean, that's one of my favorites, but the P-47 was not designed to do what that plane's supposed to do. The P-47 was kind of like a bathtub that has some machine guns attached to it. It's like a flying tank. Yep. But see, even the P-47, where's the P-40? The main landing gear on the airplanes are a good indicator of where your center of gravity is. The center of gravity being right here, right? Your control surfaces, you need a bigger control surface. Look at the control surface on the 47 versus the Focke-Wulf. The Focke-Wulf has that little baby control surface, but that little baby control surface, A, doesn't make as much drag, and B, it doesn't deflect a lot. But since it's so far away from your center of gravity, that little guy can outturn that big guy over there. Pretty cool, huh? Yeah, that's also a flying tank, and that's not a flying tank. Ooh, a Heinkel. Look at that. The what is that? An HE-123, I think. Messerschmitt 262. There's a 262 in here somewhere. I don't know where it is. There's the Enola Gay. Paul Tibbets. August 6, 1945. That is the plane that dropped the bomb on Hiroshima. Like, HE-163. There you go. That's the name of it. I'm late. Have we seen Discovery yet? I don't know. No, I haven't seen Discovery yet. Have I sold you guys on this museum yet? It's pretty good, dude. It's pretty good. You've seen probably about a 16th of the museum at this point. Luckily, it had no firepower. I know some stories about Brazilian P-47s tanking Focke-Wulfs like nothing. Yeah. On a side note, what tripped a lot of people up, the center bomb is actually the fuel tank. The bombs are under the wing. It's got a small tank under its belly. Could hold actually additional tank. Yeah, cool. Have I sold you guys on this museum? Because I ain't showing you the whole thing. You're not. We'd be here for hours. We got a rocket launch to see. 917 for the New Centaur Lima launch. Oh, my baby. That's one of my favorites, dude. P-38, man. You want to know what's crazy? That's not Dick Bong's P-38, but he flew that P-38. He flew that exact one. Who's Richard Bong? Most amount of kills in World War II of anybody. He flew a P-38. Of anyone. He was the highest scoring fighter ace. And he flew a P-38. This guy was absolutely savage. He had like 300 kills. It's something absurd. I don't remember the number off the top of my head. Dick Bong. Richard Bong is his name. Dude, guy was an absolute animal behind the seat of one of these things. Nothing beats the Mosquito. I mean, Tessa, I agree. You know I love the Mosquito, but the P-30, dude, turbo supercharged. Turbo supercharged. It's turbo supercharged. That's badass. And it flies basically as fast as a Mosquito. It's turbo supercharged. You can't hate this. That plane is awesome. It's turbo supercharged, bro. Thunder Cougar Falcon Bird. And it's intercooled, too. It's badass, dude. That plane is so sick. Yeah, Jam, water injected. It has an air-to-water intercooler. That's freaking sick, dude. What an awesome airplane. He's the highest-scoring American ace, period, dude. Guy shot down a lot of people with one of these things. Leading edge intercooled. What the heck was Kelly Johnson smoking, dude? Kelly Johnson designed this plane, guys. The same guy that designed the SR-71. He designed this when he was like in his late 20s. All right. Sure. That's not okay. We got another delay? Oh, no. Lima, how far is it out, dude? 9:37. Okay. The heck was Lockheed? No, dude, what the heck was Kelly Johnson about? Who comes up with turbo supercharging an Allison 1710 engine and then intercooling it on top of that? This guy was thinking about staged turbines in like 1942, which is just, all right. Okay, sure. Sure, why not? Anybody know what that is? Last, please. You know what's actually funny about that? They were all from like 100 and 150 yards. He was a terrible shot from distance. Nice. That's an airplane. Yeah, you're not wrong. We got time for more tour guide EJ. That's not a Spitfire, guys. That's a Hurricane. Hawker Hurricane. The Spitfire gets all the credit, but that's the reason why England still exists. See that plane? That's the reason. Hurricanes flew a lot more missions than Spitfires did. Do they have the Tuskegee Airman planes? That's a P-40? Yeah, there's a P-40 right there. See the shark teeth? Yeah, that and radar. Yeah, radars. Yeah, very good point. There's the P-61. Dude, that plane is sick. Yes, that is a helicopter that was made in Minecraft. There's the P-40 right there. So, fun fact, the P-40 has the same Allison 1710 engine as the P-38. The thing is that the P-40 engine, the P-40's engine is not turbo supercharged. So the P-40 was a good fighter for like 1938. By the time World War II rolled around, this thing was not the best. Not the best fighter around. Kelly Johnson fixed that problem with the P-38. Turbo supercharging. All of a sudden, this engine with extremely low compression is really good. It's naturally aspirated, that's right. And then there's an F4U right next to it with its gull wings. Highest kill-to-death ratio airplane of World War II right there. Corsair pilots had about an 11-to-1 KDR average. So Richard Bong in the P-38 had the most amount of kills total. But F4U pilots averaged the highest KD, kill-to-death ratio, in World War II for any plane. Where's the turbo encabulator? Well, it's over there. See it? Most successful squadron in the Battle of Britain was the Polish wing. I mean, yeah, those guys, Poles can fight. They're pretty good. They can fight, historically speaking. There was a Cessna back over there, yeah. This is a plane that thinks it's a narwhal, you know. Actually, I don't really know too much about earlier planes. That is a Loening OA-1A seaplane. Cool. Nice trophy. Right there, the yellow, the plane with the McDonald's color scheme. No, that's the 367-80. The 367-80 is the prototype for the 707. This plane flew upside down, by the way, on its test flight. the test pilot was named Tex Johnson. And Boeing was showing this thing off at a huge thing in Seattle, right? And there was the like boat races, and a bunch of people showed up to these boat races on the lakes in Seattle, right? And there was this huge thing, and they made it this huge spectacle. Plane flies over the horizon, frickin' does a barrel roll, not an aileron roll, a barrel roll. So rudder and elevator. Guy does a barrel roll in that plane, right? Brings it back down, flies it away. Everyone sees this. Everyone sees it. And, you know, all the Boeing executives that are on board are like, what the hell are you doing? And he turns around to them and he goes, I'm selling airplanes, baby. He kept flying. And sure enough, the 707 basically changed the entire way we think about passenger airline travel. It's, what are you doing? I'm selling airplanes, dog. Let's do this, you know? So badass, man. I have not seen that, can't see.
Go and throttle up.
There's a picture somewhere around on the internet. There's a picture of someone taking a camera and looking out that window and seeing the wing above them. Not below them, above them. What are you doing? I'm selling airplanes, baby. Guys, the thing about the 707 and what made that thing so damn good. Okay, so if you look at it, here's the thing. Look at a 707 from the side. And just, let's look at the nose. Just the nose. What does that look like? All right, well, here, let me give you a hint. So that's a Boeing 738. It's a 737-800. They still make these. Still make them. Look at the nose. You mean this picture? Yes. That is the picture. So the 707 can trace its heritage directly to the Boeing 737s that are still made to this day. The 738, and I mean, unfortunately, the MAX, which tarnished the 737's reputation, in my opinion. 737 is still one of the best planes ever designed. Yeah, that's the picture I'm talking about. Yep. So that's a picture. What are you doing? Selling airplanes, baby. That's badass, dude. How sick is that? Is that cool or what? That's also a good picture, Lunfront. Neat. There's ground footage around. Yeah, there were a lot of people, you know, got some camera footage because they were there was boat racing going on that week when they were testing it in Seattle in the early 60s. Or at the city of Seattle. Oh, 55. No, in the 50s, excuse me. Sorry, I wasn't there. But anyway, so the interesting thing is that you look at a 737, it looks kind of similar, right? The crazy thing about this is that what Boeing did with the 707, right? They needed to make a smaller, more regional version of this plane. So they took it, they shortened it, and they gave it two engines. They took that engine off, they shortened it, and they just put two engines on instead. And that's what the 737 is. 737 is a shortened two-engine version of a 707. And that design still exists to this. They still make them. And there's no signs of stopping, even though they fricked up badly with the MAX, but they fixed it now. So dumb. But if you look at all the different variants of a 737, right? There's a good picture here. Look, so Boeing started small. But they knew that over time they could keep expanding it and keep expanding it and keep expanding it and keep expanding it. They can make the plane longer and longer and longer and longer. The reason why they knew that they could get away with it is because, well, they already made a long version of this fuselage in the 50s. They knew that this could work. That's part of the reason why the 737 has such longevity in its design. Because the 707 precludes it. And they started with the 100 over here, and then they made it bigger, and then 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 bigger. 738. To the point where the 737s or the 739s, the Dash 9s here, are about as big as a 707 was back in the day. But with 2 engines. Crazy thing, these things have 2 engines, and it's probably more powerful than the Dash 80 with 4. Don't forget that they use the 707 to make KC-135 refuelers that we still fly. Yeah, Tikani, that's another good point. Yeah, good call, man. So, and I saw you weren't the only one that mentioned this. The funny thing is that when Boeing released these newer versions of 737s, they took KC-135s, and because the engine mounts are pretty much the same, they started mounting 707 or 737 engines. I believe they're CFM 56s. Don't get, I might be wrong though. Tikani, you tell me. They started mounting newer 737 engines on KC 135s and basically made a 4-engine 737. Pretty cool, huh? Look at that. Look at that thing. 4-engine 737. That's pretty cool. I mean, that's not it, but if you look at the original KC-135, look, it has 707 engines. And then they stopped making the 707, right? And then they've started putting CFM 56s on them. It's a 4-engine 737, dude. Because the fuselage has all been the same. It's such a good design, there's no reason to change it. The F-108 is the same as the CFM-56. There you go. How neat is that, huh? Look, they even block 45 glass cockpit. They're just lifting 737 components and just putting them in here at this point. That's what they're doing, isn't it? And now the 46 is a headache. Oh yeah, the KC-46. What is that? That's a 767 tanker variant, right? And then there's the P-8. The P-8 is a 737 maritime reconnaissance plane, right? But yeah, look, it's just a 4-engine 737. That's pretty cool, dude. I'm just saying, that's kind of neat. I want a 707 Max. I suppose if you went to Boeing and asked them to make it, they'd probably build one for you. Man. What are FedEx and UPS planes? MD-11s, KC and XKC, well, not XKC-10s, they're XDC-10s. Anti-submarine warfare, there you go. P-8 is the Dash 8 with Dash 9 wings. There you go. Pretty cool, huh? Dude, look at how many planes we've talked about that are derived from the 367-80. That's why that plane is here. Boeing is still making planes to this day that can trace their lineage directly to that plane. Pretty cool, right? There's a reason why it's in the museum. Tex lived up to what he said. He sold some friggin' airplanes, baby. That's a Junkers Ju-52 right there. That was like it's a German passenger plane. There's a German airliner. You'd see it has the Lufthansa livery. Yeah, that was a German passenger plane. Basically during the interwar period and through World War II. 777-300 is still the best looking plane and you stand by that. That's a funny way of saying 747-400. That's a 307 right there. It's a passenger B-17 for what it's worth. Oh, yeah. Concorde. Supersonic transporter. This is a passenger plane that can fly Mach 2. It has 4 Olympus 593 engines in it with a Snecma afterburner. Because how much thrust do you want? Freaking all of it. And very, very trick ramp intakes. Ramp intakes are pretty, that's fighter jet stuff on a passenger plane, which is pretty cool. And it can super cruise. What a bamf freaking aircraft this thing is. I love Concorde, dude. That and the 747 are my two favorite passenger planes. Like, it's not even close. It's Queen of the Skies and the fastest. Like, would you expect anything less from me? I don't think so. Oh, dude, what a monster. Those Olympus 593s, those jet engines are no joke. Those are the same jet engines that the British put in the Avro Vulcan. And the thing is, they used the thrust to keep the damn Vulcan flying because the thing was so freaking heavy with all the bombs, right? With this, they were like, well, what if we take this really high thrust engine that's used to get a bomber up in the air? We have the French put an afterburner on it, and then we put 4 of them on an airplane. And whoop-de-doo, now you have a plane that can go 1,500 miles an hour. That's pretty good. It's pretty fast. The 727 and the L-1011. The TriStar is my favorite tri-jet, Fluffy, and it's not even close. Because when Lockheed decides they want to make a good airplane, they make a good airplane. Phil Collins played Live Aid in England and then flew on Concorde to Philadelphia and played Live Aid there in the same day. That's freaking cool, dude. Oh, he's called Reed, isn't it? He's a French. Didn't it have like 400 times the fuel consumption with afterburner? Yeah. So you need a lot of thrust to get this thing.
If the 747 is the queen of the skies, then Concorde is the king.
Nova, what did that say? If the 747 is the queen of the skies, then Concorde is the king. Yeah, I'll take that. That's fine. Yeah, that makes sense, dude. Maxer cut a Starlink set. Yeah, I saw that, dude. Yeah. This thing could cross the Atlantic in it's 3 hours and change. I think the fastest was 2.5 hours, man. She's a monster. Oh. There's one of its landing gear. Or no, that's an A330. Oh, that's A340's landing gear. Oh, I stand corrected. Maybe you should read next time, idiot. I don't want to show you guys the whole music constellation. I don't want to show you guys the whole museum. Just because I want you guys to go here and see it. You should go to this museum. Hopefully I've sold you on it. It is awesome. Dude, there's so many good planes here. Refrigerated windows. Connie is another Kelly Johnson design. Man, is that a pretty airplane. And the cost of admission is, tell him, Gaw. Nothing. It's a federal museum. It doesn't cost anything. You just walk right in. Parking. Yeah, they charge for parking, dude. And that, you know what? That's fine. I would gladly pay $15 to go in here. Like $15, like, all right. Even for foreigners? Yeah, of course. I mean, you still got to pay for parking, but yeah. soon as I can afford a visa and a plane tickets, you could take me here and hold the camera. I'll hold the camera up to stream. All right, man. So you guys see that thing? See that little old Cessna up there that's painted with the roundel right there? See that? It's just an unassuming Cessna, right? That's what it looks like, yeah? What is that? I think that's a... I forget the model number. I know it's an old one, right? It's no big deal, right? Looks pretty unassuming. It's an O1E. That's a Scout. So those planes right there, they look really unassuming because they are. That's a forward air controller plane, all right? It's called a FAC, F-A-C. Forward air controller was a thing that was thought up during the Vietnam War. Reason why is, I don't know if you guys have ever seen Vietnam. I've never been there, but I've watched a lot of footage from certain conflicts in Vietnam, right? Vietnam is a very dense jungle. There's a very thick canopy. It's hard to spot stuff from the air. So what forward air controllers would do, right, is because the plane flies you could fly pretty low and pretty slow to the ground, relative to the ground, forward air controllers would basically go and scout out the canopy and scout out anything from landing zones for helicopters, a good LZ, where enemy positions were, where Viet Cong was, if they were hiding in the canopy, where the NVA army could be. These guys flew around in these damn planes, 1,000 feet off the ground, getting shot at most of the time with RPGs and AKs and all this other fun stuff, right? That you really don't want to be in one of these little guys, right? When somebody starts shooting at you, right? But the forward air controllers are nuts. They were crazy. They would fly around basically right off the canopy looking for stuff and radioing it back and telling people where the enemy was. That's what they did. That's why that plane's hanging right there. It's pretty unassuming because it is. They just said, here, have this civilian plane. We painted it green. It's a military plane now. Go. Tell us where everything is. These guys had plot armor for sure. 9-hour drive for you. I'll pick you up on the way. Cool. That's why the OV-10, the Bronco. Yeah, yep. Pretty crazy, right? Forward air controllers. Read about them. Those guys had balls of steel. Like, balls of steel. You're going to fly that over Viet Cong positions? Okay. Oh, okay. Falcon 9 is in propellant load. Good. Great. Grand. Wonderful. Is that what Treetop Flyer is about? Part of it, yes. Yep. It's over in Vietnam, chasing NVA. The government taught me, and they taught me right. Stay down, under the tree line. You might be all right. Treetop Flyer. That's a great song, dude. Yes, that is what that song is about, yes. Only it's a guy that did forward air control that now runs drugs for people. Or anything. Where is the Bell X2? I don't know. Sorry, I got a little distracted, Clayton. That's a V1. So that's a pulse jet. Very primitive intermediate range cruise missile that the Germans came up with. We lifted that and came up with a Regulus missile based off of that, for what it's worth. Can't snuff the rooster. My God. Excuse me, boys. I gotta say hi to her. What's up, baby? How you doing? Hey, where am I? What happened? Why are we up here? I don't want to be up here. I want to be over there. I want to boot the snoot. How do we get over here? I've streamed right from the staircase, Louise. Oh, yeah, that's right. Oh, what a beast. I love that thing. What a freaking absolute beast mode of a freaking vehicle. Just freaking. Oh, there we go. All right, we're back. We're back. Oh, hello. I love that thing. That freaking thing changed my life, dude. I'll tell you that. Seeing the shuttles go off when I was little made me love space. Like, really love space. Like, an unhealthy problem. Oh, she's so pretty. Look at that. And they have the arm here too. That's a real one. That's the real arm. Oh, we should have never stopped building these things. Canada! Oh, yeah. Oh, Canada's like, we contributed, buddy. Oh, yeah, guy. Yeah, look at that. We're Canada. We have contributed. Friend. Oh. See up there? That's a Tidris. Tracking data and relay satellite. That's a mock-up, but yeah. Hey. How you doing? Was there an Aegina over there? Oh, yeah. There's an Aegina sitting over there. Neato. What's the orange rocket on the side? Orange rocket. Orange rocket. I'm not sure what all this stuff is. I would have to read. I am not confident enough to know exactly what all this stuff is. They're all missile prototypes and stuff. See last. What's up? What's up, dude? I'm kind of glad they didn't clean her. No, hell no. This thing, dude, no. Don't clean it. Hell no. Don't clean that thing. It should be preserved exactly as is. What an absolute G this thing is. Dude, what a freaking unit, man. Oh, there's the Space Lab, too. So, that's the Space Lab, Space Lab Laboratory module. It's basically a space station module that stays inside of the shuttle's payload bay, and the shuttle can fly up and basically be a mobile space station for a couple of weeks, right? And all you got to do is just take the module and just plug it in. You plug it into the power systems on the shuttle. The shuttle's payload bay basically, well, it has the space flight equivalent of a bunch of outlets inside of the payload bay. You just plug in your payload, you're good to go. You can get power anywhere up and down the rails on the payload bay. Not a lot of people know that. You can get power, you can get life support, you can get whatever. It's all a modular system inside of the payload bay. You just put whatever. I think Starship should do something like that too. Hey, oh, Guy, what an absolute G your U is. Oh, your unit is. Oh, thank you. Tidris is no longer. That Tidris is no longer a mock-up. Oh, neat. That's cool. You know what the crazy thing about that module is? That's flown. That's flown hardware, guys. That's been to space multiple times. Think about that for a second. Think about where that thing's been. How much weight is the shuttle compared to Starship? Shuttle is about 60 tons, if I'm remembering correctly. Starship is closer to 100, if I'm remembering correctly. Somebody just make sure I'm not wrong. And that's a jungle gym. What a monster. Look at that monster. Look at this damn thing. How the hell did this thing fly into space? This is unbelievable. It kills, like, every time I see it, man. Like, what? What? All right. Woof. Are RS-25s bigger in size than Raptors? Oh, yeah. Yeah, RS-25s are huge, man. You can stand up inside of the nozzle. Like, if we could, I mean, I wouldn't do it. You'd destroy the copper linings inside of the nozzle. But if you could stand, like, inside of the nozzle right there, yeah. Shuttle engines are huge. You don't realize how big they are until you see them up close. They're gigantic. I could stand in there, no problem. Like, I could stand and do this, and I'd be touching the top of the inside of the nozzle where the mouse cursor is. That's like a little more than 2 meter right there. It's like 2.5 meter at the widest. It's huge. The engine's gigantic. We have 22 minutes until launch. I know. I said we have 22 minutes until launch when you said it like 2 seconds ago, dude. Apollo telescope mount to your left. Eh. Right. That's left. That's right. All kinds of good stuff in here. I thought I saw a Venera over here. I think there's a Soviet Venera probe sitting in the corner, if I'm remembering right. It should be right there. Oh. Dude. That's real. That's a real Venera probe. How the heck did they get that? How did you what's that top hat looking thing on the ceiling? Dude, I don't know. I don't know what half of the stuff is in here, to be honest. There's a lot of crazy satellites. Ah. Well, this is the floor. We are now on the floor. Oh. I fell off of a truck. Yeah, a space truck. Which shuttle is this? That's Discovery. So anyway, hopefully I sold you guys on the Udvar-Hazy Center. It is, yeah, that's the Stephen F. Udvar-Hazy Center. It's an annex for the Smithsonian, the National Museum, the National Air and Space Museum. That's the Smithsonian Institution Stephen F. Udvar-Hazy Center in Chantilly, Virginia. It's by Dulles Airport. Go there. You will not be sorry. It's right by the airport. You can fly right into Dulles, then take a car right there, take a taxi right down here, boom, you're right in the museum. I know because I've done that. I did that with my dad. I forget when. I think for like my 22nd or 23rd birthday, me and my dad did that. That was my birthday present. He bought us tickets to here. We took a plane to Dulles, got in a taxi, like took an early morning flight to Dulles, got in a taxi, came down here, took the taxi to there, spent the entire freaking day in the museum, and then when the museum closed, we took a taxi back to the airport and flew home. Pretty good, man. That was a long time ago. That was like 15 years ago, dude. Are the nozzles more similar in size to a Raptor vacuum? Yes. Yeah, that's about right. Dude, me and my dad have gone on some pretty awesome birthday present trips. When I was 12, my dad and I took the train from Boston. So this was in 2000. My dad and I took the train from Boston down to New York and saw all the sights around New York City. This was in 2000. We went to the top of the Empire State Building. We saw Central Park, Saw Times Square. I don't know why, but we didn't go to the Intrepid. We went past it. That was a big mistake. We saw Battery Park, Ellis Island, Statue of Liberty, and we went to the top of the Twin Towers. Pretty good trip. My parents were pretty good to me. Pretty damn good. Pretty damn good, dude. You should take them to Wrigley. It's a good idea. Nice, Fluffy. All right. Well, I'm happy this launch got pushed a little bit, right? Because that means I got to show you guys that, which is pretty cool. Yeah, that museum is awesome. That museum is like my top three in the United States. The Smithsonian, the Museum of the Air Force, which I haven't been. I just know it's awesome because I read the list of planes that are there, and missiles and rockets, and then Pima. And then I think I like the Smithsonian the best. Then probably Pima, then the Museum of the Air Force. The reason why is because I haven't been there. Other museums, Evergreen in the Evergreen Museum in Oregon. It's in the Willamette Valley. That's an awesome museum. You should go there. The Museum of Flight in Seattle is fantastic. All of Boeing's prototype planes are there, with the exception of the 367-80. Yeah, Pima in Tucson, Arizona is unreal. Every single bomber that the U.S. has like ever made post World War II is there, which is nuts. Ari, yes. I don't want to repeat your question on stream, but yes. I told you Park Drive is always. I didn't say Park Drive. I said through the park. Kansas Cosmosphere is pretty good. I wouldn't put that in my top 5, but it's a good museum for sure. You need to go to the Boneyard. I've been to Pima. Never been to the actual Boneyard, but I never went to the Titan II Museum, Turkey J, in Green Valley. Never went. I know it's an extension of the Pima Museum. There's a full Titan II missile silo that you can take a tour of, which is really cool. I love Titan IIs. Titan is one of my favorite Cold War rockets, save for like the Saturn. Oh, SpaceX is live. Let's do this. All right. So, let's cap off this space news with some rocket launches, baby. I didn't expect this space news to go this freaking far, but this launch was supposed to be an hour and a half ago, but hey, that's truck driving, man. That's the way she goes. Henry Ford is pretty good, Dark Room, but I wouldn't say that's an aviation museum, but it is an awesome museum. I do, Redstone, I do. There's so many places I need to go, dude. This is a Falcon 9 mission. So this is the Nusantara Lima mission. The Nusantara Lima mission is an Indonesian high-throughput telecommunications satellite that's operating in geostationary orbit as a replacement for the Nusantara 2 satellite, which failed to reach orbit on a Long March 3 in 2020. Oh no! Anyway, it will deliver high-capacity connectivity for PSN users across Indonesia's over 17,000 islands and neighboring nations. The SNL communications payload, which flies aboard Boeing's proven 702 MP platform. Yeah. Oh yeah, the 702 SatBus. That's really known for reliability, huh? Can provide more than 160 gigabytes per second of capacity, supporting broadband internet access and essential communication services through Indonesia and Southeast Asia markets. Cool. So this is SpaceX 117th mission of 2025. The first stage flying today is booster 1078 on its 23rd reuse. It's going to land downrange on a short fall of Gravitas, one of SpaceX's autonomous spaceport drone ships.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I mean, Phil, this is a pretty hefty satellite. Look at the size of that monster. That's as big as a school bus, dudes. That's a huge satellite. It's a BSS 702 is a gigantic satellite bus. That is a big boy, for sure. Probably 6,800 kilos. What is spaceflight now? Next spaceflight say? Yeah, it doesn't say. All right. Let's roll.
Hello, everyone. It's Tuesday, September 9th,
Chris!
and you are
That's
looking at
Chris!
a live view of our Falcon 9 rocket awaiting its
That's Chris
9:37
G!
p.m. Eastern Time
All
launch
right!
from Space Launch Complex 40
My guy!
at Cape Canaveral Space Force Station in Florida. My name is Chris Gebhardt with SpaceX Communications, joining you from Hawthorne, California, and welcome to our live launch coverage of the New Centaur Lima mission. New Centaur Lima will be the newest satellite in Pacific Satellite New Centaur's fleet, and the geostationary communications satellite will have the largest capacity in Southeast Asia using very high throughput satellite technology. Indonesia is the world's largest archipelago with many remote areas that are challenging to reach and provide internet. The New Centaur Lima satellite will be critical to providing essential connectivity across more than 17,000 islands, and we'll have more to share on the satellite and more about today's payload in just a bit. Right now, Falcon 9 is tracking no issues, and the New Centaur Lima payload is healthy. Weather is currently our only watch item with a 60% probability of violation. If for some reason we do have to call a hold on today's launch, we'll have a backup opportunity tomorrow at 8 p.m. Eastern Time.
Not good
The Falcon
odds.
9 team reported on console at T-minus 2 hours and 15 minutes for today's launch attempt and began their final checkouts of the launch vehicle and ground systems.
It's not TDRS. This is a geostationary communications satellite. TDRS is a tracking data and relay system. If that makes any sense. It's a similar type of orbit, but in a different latitudinal slot, or longitudinal slot, excuse me.
Checkouts, as well as avionics, guidance, navigation, and control at the T-minus 1 hour mark. At the technical readiness poll, there were no issues, aside from weather, and the team completed a final poll at T-minus 38 minutes to proceed into propellant load and launch. We're expecting to finish up that propellant load in just about T-minus 2 minutes. So while the countdown continues, let's learn more about today's mission.
Yes, let's.
Tower wheel, go for launch.
Probably can't listen to the promo music that they have in here because YouTube decides that, you know, not mine or something. I don't know. Look at all these grassy areas. From Sepang to Maruke. From Miangas to Rote. I'm not even sure if I'm saying these cities right. Indonesia is a vast nation. More than 17,000 islands bound by the sea, separated by distance. Indonesia is not only vast, but rich in culture, heritage, and spirit. Thousands of stories, melodies, and traditions to share with the world. Yet these voices remain unheard and treasures unseen. Mopeds. In this island nation, terrestrial networks cannot always reach. Between islands, signals fade. Information stops. Dreams wait in silence. Yet the sky holds the answer. Satellite networks. Limitless reach, crossing seas and mountains, connecting once what was apart. New Centaur Lima, India's giant leap. With the largest satellite capacity in Southeast Asia, it brings digital services to every corner of the nation with ease. It paves the way for equal internet access, powering the digital economy and standing as a symbol of our nation's technological progress. More than that, it bridges cultural differences across archipelago and opens a window for Indonesia to share its heritage with the world. New Centaur Lima, powered by PlayStation Network, PSN, Indonesia's leading satellite company, continuously ushering the nations into the digital era of transformation. In the mission of carrying connectivity across borders, New Centaur Lima's reach spans across the archipelago to the Philippines and Malaysia. It was born from years of dedication, combining world-class expertise, united in one grand vision. From design to reality, every bolt, every circuit carries a story of perseverance and pride. This collaboration strengthens our integrity and places Indonesia shoulder to shoulder on the stage of global technology and F-150s. From Los Angeles, the skybound Voyager traveled to its launch site, and it's awaiting its moment to fly, carrying the hopes of a nation into the boundless sky. And engines ignite. And as the engines ignite and the Earth falls away, New Centaur Lima lifts all of our dreams, breaking the limits of time and space. New Centaur Lima, a great leap towards equal national connectivity. From the sky for the motherland, uniting us all for generations to come.
And at T-minus 5 minutes and counting, teams continue to watch the weather, specifically anvil clouds near the launch site. While we were in that video package learning about the New Centaur Lima satellite, we also completed propellant load on RP-1 for stage 1 and stage 2. Liquid oxygen load continues into both stages of the vehicle. The next major event in our countdown will be the start of the retraction of the transporter erector, or the TE. Now, the TE is the large truss structure behind Falcon 9 on this graphic that you can see on your screen here. And it helps keep the rocket upright when it's on the pad, as well as helps during rollout and lift to the vertical.
Okay, so the clamp arms are going to open here on the strong back. As Chris was saying there, the strong back is where they build the stack on the strong back horizontally, right? And it's moved to the pad horizontally, and they turn it upright. Clamp arms are what hold the vehicle true, so the strong back is nice and straight and it's rigid, and the rocket is not very structurally sound like when it's not filled up with fuel, right? And it can stand up, but the tanks have to be pressurized for it to stand up on its own. So the clamp arms are open, and you'll see the strong back just move back just a little bit right there. Now, when the rocket goes to fly, that thing's gonna throw back away from the vehicle so it doesn't get cooked on the launch. Now, I know what people are going to ask. I always get asked this. What the heck is that thing? Well, that thing is there to cradle the fairing. Those are two retractable arms that obviously aren't being used right now. It's used to cradle the fairing when they're bringing the vehicle upright. It kind of wraps around it, and it's a big ratchet strap that holds the fairings in place, because the clamshell halves are actually super delicate. And when they're turning the rocket upright, it can bend and flex, and you don't want it to do that. The whole thing needs to stay nice and straight as you turn it upright.
Loading of the liquid oxygen.
Oh yeah, I gotta run ads.
Of Falcon 9 here.
Guys, I'm gonna run the ads now. Sorry, I usually do it inside of 10 minutes, but that dang ad, the new Centaur Lima advertisement was pretty cool. So I run the ads now so you don't get them during the ascent. I hate ads. I don't like them. They're intrusive. They're annoying. And if I had any control, we wouldn't run any ads at all. I don't believe in paywalling my content like that. But I do have control about when they do and don't run. If I run them now, they won't run during the launch.
Just under 2.5 minutes now till launch. Teams continuing to keep an eye on the weather.
Weather is not cooperating,
And in just
guys.
a few moments, we should be hearing the call out for the completion of liquid oxygen loading on the second stage.
Yeah, you have to touch it. Be like, yep, it ain't going nowhere. And it won't. If you don't say it, it's going to move.
Now, you probably noticed the white clouds venting from the rocket. That
Stage
isn't
2
smoke,
launch load is
that's
complete.
actually condensation.
Okay.
As the liquid oxygen warms slightly inside of Falcon 9's tanks, some of it boils off, and that gas is vented out to maintain and manage pressure inside the vehicle's tanks.
So the ground gas closeout here. The second stage liquid oxygen tank has completed filling. And there's a fuel line that goes up that transporter erector that fills up the second stage with oxidizer and fuel. Now, it's probably a good idea to have the fuel and oxidizer from your rocket in the rocket and not in the launch pad. So what they do is they blow nitrogen up the oxidizer line, and they have a vent open at the top, and it spews out all the liquid oxygen. The liquid oxygen, as Chris was just saying, when it hits the atmosphere, it immediately evaporates and turns to gaseous oxygen, or GOX, which is why you see a nice big cloud right here. The idea is to not have propellants inside of the vehicle, or inside of the launch pad when you go to
Falcon
launch.
9 is in
1
startup.
minute mark.
Okay, inside of 1 minute here, Falcon 9 is in startup. That means the onboard computers on Falcon have control of all vehicle functions. And last thing we're going to wait for here is a go from the launch director, which should be popping up here in a second.
Standing by for a final weather call.
This is a SpaceX rocket, techie, yep. "30 seconds.
Hold.
Oh,
Launch board is running.
Two-time and weather guy, doo-doo face.
And as you just heard, we did have a hold call due to a weather violation in the area, so we will be standing down from our launch attempt tonight. The vehicle and the payload do remain in good condition and remain healthy, and we do have a backup opportunity scheduled for
We're running
tomorrow
on the countdown
with a
net. We
launch
have
window.
aborted out of the count due to the red range for violation of the attached anvil cloud rule, which would not clear by T0.
Thunderstorms. You don't want to launch the rocket into those.
There with the violating weather condition not going to clear before T0, our anticipated launch time. So with that, we have scrubbed for today, and we do have a backup opportunity scheduled for tomorrow with an approximately 2-hour long launch window opening at 8 p.m. Eastern. If you're interested in more launch coverage, be sure to check out spacex.com/launches for the most up-to-date information.
I'm interested, Chris. But I'm interested in more SpaceX launches, Chris, but the problem is you didn't launch it. Dang it, Chris. What? Sorry, I'm just being a jerk. Sometimes the weather doesn't cooperate, guys. So, all right, serious time. Sometimes this happens. If you're newer to rocket launches, you don't know, like, what do you mean? We can't launch in a thunderstorm? Well, yeah, I wouldn't. It's not that you can't. It might be fine. But rockets don't have a very good track record getting struck by lightning in the past. We almost lost an Apollo mission because of that. Yeah, read about Apollo 12. Don't launch it into a thunderstorm. They yeeted Apollo 12 into a thunderstorm and yeah, it'll be fine. Yeah, all right, go. Yep, almost blew up a Saturn V on ascent. Whatever. With people on board, I'm sure that would have ended well. But But no, fortunately, there was an electrical engineer in NASA's in Johnson Space Center in Mission Control that figured out what the problem was while the vehicle was going up and actually fixed it, troubleshot it on the fly and fixed it. And Apollo 12 ended up being a very successful mission. But you don't want to roll the dice like that. SpaceX isn't going to roll the dice like that, especially with a customer's payload on board. If it was Starlink, it probably would have launched. But you don't screw around when you have a multi-million-dollar payload up there, especially if it's not yours. Right? So it's not really that they couldn't launch. Falcon 9, I'll be honest with you, at this point, Falcon 9 probably could have launched and it probably would have been just fine. But probably would have been just fine, doesn't fly, like I said, when there's a $200 million payload on board the rocket. And clearly the hopes and dreams of an entire small island archipelago in Southeast Asia. Look, man, Florida's called the Sunshine State. It'll be sunny at some point. So just wait another day. What's one more day? That means nothing. That's why it's not that they couldn't do it right now. It's that you don't want that getting hit by lightning on the way up. Just wait. The weather changes in Florida basically on an hourly basis. It'll be fine. The weather nerd in me gets irritated that they call it anvil cloud versus a cumulonimbus cloud. There are limits to flying into thunderclouds, even with airplanes. I mean, Aqualex, I wouldn't do that. I'm sure somebody would get away with it at some point. I'm sure somebody would do that. I'm not doing that. I mean, I know enough about planes to know that that's probably not smart. I probably wouldn't do that. Archipelago, something. Anyway, well, start saying archipelago like that, I beg you. No, I'm not. I'm going to say it however I want to. Pilots that fly into hurricanes are a special kind of nuts. Yes. Yes, they are. All right. So, guys, with that being said, that's going to end our space news for the day. Unfortunately, we saw Scrub, but hey, that means we just get to watch another potential rocket launch tomorrow. That's pretty good. Oh, we actually get to watch 2 rocket launches tomorrow. Tranche 1, Transport Layer B, is a Falcon 9 launch is launching from Vandenberg at 10 in the morning tomorrow. Fudge. How are we going to do this? I want to play Stationeers for after hours. But I also want to go get some sleep so I can get up for that launch at 10 in the morning. We could get up for the launch at 10 in the morning, and then we can work on the car right after that. Gives me an excuse to get out into the shop early for Wednesday. How much does a scrub cost? 100,000, maybe? $100,000, Googer, maybe? Keep in mind, that's peanuts. Not for SpaceX, that's peanuts for anybody. A scrub doesn't cost you very much. If the thing blows up, oh, that's going to cost a lot more than that, right? $100,000 is a lot of money for you and me, but that's negligible amounts comparatively to the money that you need to make something like Falcon 9 work in the first place. Did you ever play first-person shooters? Petrie, in another life, I was a semi-professional Counter-Strike player. 20 years ago. I'm still good at Counter-Strike. I'm pretty good at it. The one game that I have... Kerbal is... I have the most hours in any video game in Kerbal. The second most hours is in Counter-Strike. Still, to this day. Maybe Cities has gotten close. Maybe. I played semi-pro Counter-Strike Source. I played 2 seasons in Open, 1 season in IM, and 1 season in Maine with the Cyber Athlete Amateur League, or CAL, at the time. Yeah, it was pretty damn good, dude. I decided to stop playing Counter-Strike because I decided to go to college instead. Because it was 2006, and, you know, well, you gotta go to college. Look where that got me. Wait, what are my values? Stationers is being a bit iffy today. Well, yeah, dude. Shooters games that I've played, let's see, let me go down the list. So Counter-Strike's at the top.
Discovery.
I played Call of Duty 2, I played Call of Duty 4, I played Medal of Honor Frontline back in the day. I played Battlefield 1942, Battlefield 1942 Desert Combat, Battlefield Vietnam, Battlefield 2, Battlefield 2142. I played Battlefield 3, Battlefield 4. I'm going to play BF6 when it comes out. PlanetSide 1, PlanetSide 2. And these are, like, when I tell you these games, these are games that I easily have over 100 hours in, at the very least. That's like at the very least. Most of these is way more than that. I played a lot of video games growing up, dudes. A lot. Live and die by the video, man. I played Star Siege Tribes back in the day. Doom, Quake. I played Tribes the most out of, like, 1990s Twitch shooters. Star Siege Tribes, Tribes 2. Played UT2K4 back in the day. Bring back jump shooters like that, man. Those are fun. Not battle royales. I hate battle royales. Battle royales suck. Shazbot. I know you said you made it to MLG Orlando. Ever get into StarCraft 2? Yeah, Dukas. I did get into StarCraft 2. I got into the professional, well, not into the, like, watching the professional players. I was at MLG Providence in 2011, and I watched Lenok, like this 16-year-old kid, just kick the trash out of everybody, which was pretty fun to watch. I never played StarCraft. I never streamed StarCraft 2 professionally, though. Dukas, I really like StarCraft, and I wanted to get into StarCraft 2, and I know StarCraft 2. The problem is I suck at StarCraft. I'm not a good StarCraft player. The problem is, dude, is that I just always wanted to 1-1-1 BC rush people, and if they figure out what you're doing, you don't really win. Yeah, I would always, if I was playing against Zerg, I would always BC push them, or Wraith push with BCs. It's like 1 battlecruiser, 2 Wraiths, and Muta's late game for Zergs in Wings of Liberty. So I just would just, if they didn't figure out what I was doing, I just laid waste. I just parked the BC over their base and just killed everything. People got so mad, but I never got past Gold League, dude. I'm terrible. I'm a terrible StarCraft player. So bad at that game. Dude, somewhere, I don't know where that ended up. Somewhere around I have a MLG Providence poster, and it's signed. I have it signed by, who was on that? So let me go down the list for SC2 players circa 2011. Huck is on there. Idra is on there. In Control is on there. I got In Control's autograph. DRG is on there. MC is on there. He's OGS at the time. Lenok is on there. Artosis, Tasteless, Shao, Cats, Drooby. I think it was Cats and Drooby. I think Cats and Drooby were on there. This isn't going to make sense to a lot of people. If you know StarCraft, then you probably know this. But yeah, I think that's it. I never got Scarlet Signature, Dark Silver, no. Tribes is amazing, Snarfer. It was an amazing video game. These were all really top shelf StarCraft players from 15 years ago. So Artosis and Tasteless aren't, well, they were professional StarCraft players, but Artosis and Tasteless were the English commentary on GSL. So Korea's professional StarCraft league. They were the English commentators. I don't know if they still do that. If you guys know Day 9, Fun Day Mondays, Day 9, he still streams. So two things. One, Tasteless is his brother, right? Second thing, Day 9, the Day 9 daily is kind of what clicked in my head of doing educational streams. Because Day 9 was teaching people about how to play StarCraft with his streams at the time. And I saw that and I said, dude, that's a good idea. Maybe I should do that with KSP. That proved to be a good idea. That was a good idea. But yeah, I was inspired from Day 9 back in the day. That was, once again, that was over a decade ago, easily. You have Total Biscuit? I do not have Total Biscuit, no. That's a shame. I have In Control, though. That's kind of cool. Hey, Drunar. All right, man. Good night. Question: when national security missions at the Space Force satellites get brought into Kennedy, do they use an AC-130 to bring them in? No. Ship watching, an AC-130 is an attack aircraft, not a cargo aircraft. An AC-130 has no payload space to move a satellite inside of it. Do you know why? Because the payload bay of an AC-130 is filled with guns. A regular C-130, no. They would use a C-17 or a C-5. Satellites are big. Very big. I know. The lull thing is a picture of Total Biscuit. Yeah, I know, Mace. Yeah. Going to college got you... Well, going to college got you a career in video games, just not the way you plan. Yeah. Tasteless and Artosis still stream together for StarCraft 1 ASL English. No crap, Mace. That's cool. You ever play BattleBit? No. I got confused. I meant a cargo variant. No, C-130 isn't big enough to move the satellite and all of its paraphernalia. It's usually a C-17 or a C-5.
Discovery, go at throttle up.
So AC-130s are a C-130 that some psychopath came up with the idea of just mounting a bunch of guns on the side of the damn thing. Here, let me show you. Everybody knows them from Call of Duty. So here, take a look. So that's an AC-130. Somebody came up with the idea of mounting a freaking howitzer. Well, it's not a howitzer. It's a 105. It's a 105 millimeter. And then there's a 40 millimeter, I think, as well. And then there's two miniguns somewhere on this damn thing. And what this thing does, it's basically a flying artillery piece. C-130 basically just flies circles around a target, right? And they have targeting equipment on the landing gear right here that look, and they look for targets, and it's basically a flying tank. I know Space News is over, but did you see this? Oh yeah, it's also got Hellfire missiles on it, because why not? That's cool, spoiled, neat. So that's a 105 millimeter. That's not a cannon. It's a 105 millimeter gun. The 105 in the U.S. arsenal is rifled, so it's a gun. It's not a cannon. Cannon is smoothbore. That's what the Abrams has. The U.S.'s main battle tank doesn't have a gun on it. It's a cannon. The reason why they have a cannon over a rifled gun is so they can shoot sabot rounds out the front. Cannons, with a cannon, it offers a wider range of munitions. Today you learned. Those airframes are so versatile. The C-130, do you know what, when you talk about stakeholder expectations with C-130s, you want to know what the crazy thing is? Do you know what the stakeholder expectation for a C-130 is? Move what a boxcar can move in the air. That's it. The U.S. Air Force went to Lockheed and basically said, we need you to build a cargo plane that can hold as much cargo as one standard railway boxcar. And Lockheed said, all right. And they said it needs to be able to land anywhere. And they said, yeah, sure. All right, whatever. And they cooked that up. There's a reason why we still make C-130s. The C-130 was designed in the 50s. We still make them. The newest version, I think the newest version of the C-130s are the C-130J, I think. The J is the newest one. The idea came from the AC-47. Well, yeah, yeah, the AC-47 was, yeah, in Vietnam, they needed close air support. So they took a C-47 transport plane, punched out 3 of the windows, and put miniguns in their place instead. Yeah. Oh, yeah. Yeah, good stuff. Yeah, that's what they did. They just punched out 3 of the windows and replaced them with 3 Gatling guns. And it works. Yeah, no, the idea, it's a good idea. It's not a stupid idea. That's because this thing can fly up there and it can just stay up there and circle. What are they going to do? Shoot it down? You're not going to send this into a place where the air is contested. You send this in a place where you have air superiority and it just sits up there and kites people all day. Spoiled Fruits link is awesome. Yeah, the RDRE from Venus. They're making some pretty good strides, dude. That's really cool. You need close air support. How about a whole cargo plane's worth of ammo? There you go. Smart. It's a good idea. Yeah, see? Yeah, just miniguns. The crazy thing is that this is something that this was a field modification. This isn't something that the Air Force was like, yes, we should do this. This is a good idea. We need to buy AC-47s now. No. Some crazy pilots in Vietnam were like, hey, let's take some Gatling guns off of a Huey and mount them in this plane. Does that look like something that was made in a factory? That looks like they took those and just kind of bolted them down inside of the fuselage and actually punched the window out. Look, there's still holes where the rivets were for the window. They're just like, yo, let's mount miniguns in the window. It's called a field modification. Basically, when nobody's saying do that, and then they're like, do that, and they did this, and now you have a freaking gunship. Yeah, also square windows. Yes, yeah, right. Yeah. Yeah. Yeah, see all those? For every red line, there's probably 5 bullets. 5 to 6 bullets per, like, for every red line. There's a lot of red lines. Miniguns. So you could see where the plane circled around and it kind of made like a tornado looking thing. It's a time-lapse photo, yeah. See the plane went over here, right, and then banked and turned that way, so the plane turned. 5 rounds per tracer, yeah, there you go. So for every one of those lines, there's 5 more bullets. Because minigun. Miniguns are cool. How is our station wagons post doing? Let's take a look. Bring back station wagons with fake wooden trim on the sides. That's it. That's the post. 133 likes, 27 replies. Yeah, that's pretty good. Nope, not liking that. Yep. Damn it, Logan! Stop doing that! Shouldn't be called a minigun when they do so much damage. Yeah. Ouch, we will agree to disagree on this one. Not sure why, but I never liked those trims. Beauty's in the eye of the beholder. I'm disappointed in you, Serge. I'm disappointed. I'd just be happy with station wagons. Yeah, but the wood trim is what makes it, Joey. Damn. As an EV option too, please? Sure, why not? Yeah, whatever. It's fine. Do it. No! No, man, fuck you, Andy. Fuck you, what do you mean? What the hell is this? Oh, God. Oh, God. Oh, God. No. And on that bombshell, it's time to end. Let's go play Stationeers. Oh God, I went way too far into this thread. Oh jeez. Looks like the space shuttle had the bung bung with a freaking wooden crate. That's so bad, dude. I'm switching. All right. I'm switching. All right. Yep. Never go too far into Twitter, okay? Never go too far. It's pretty ratchet in there. Yes, I said ratchet. We also called it Twitter, didn't we? Obviously. Get with the times or past or something. I don't know. Didn't you say you would sleep? If you want me to sleep, I'll sleep if you want. No, that's awesome though, Cyborg. Stationeers, get to the rocketry. I was gonna play. We're only gonna play Stationeers for a couple hours. It ain't no thing. I'll be able to get up for that launch. All right, so I'm gonna jog the YouTube VOD. I'll be right back. We'll switch over to Stationeers. Space News was educational. I'll be back in a second.